Okay. Press that button. I smashed that start button. Stream number 36. All right. We're up to 479 unit tests. We have vector context parsing at the expense of having a lot of messy code. Got rid of all to-dos in the code, so just have a bunch of to-do comments that are going to mark all of the work that has to be done to clean it up. So I guess might as well just work this in order, right? Yes, so add child is not a good name. What are we doing here? We're adding a part to the composition. Add part to composite. The name is what we use to put into the key. Is the name only put to string? Well, yes, but I'm referencing it in two places. Find all references. Oh, did I decide to make function arguments unformatted parts? I think I did, yeah. Okay, that makes sense. And it's the formal argument name. Yep, okay, and that is a string. Reference to a string. Actually, hold on. Okay, yeah, that is borrowed, right? Borrowed format. Okay. Hey there, Adjective Allison. Going to ask me yesterday, is the code open source? No, because of job rule 3. Job rule number 3. Job rules number 3. Can't participate in open source. So there's no license on this, meaning it's all rights reserved by the copyright holder, which is me, and no one else has a license to use it. Unfortunately. Someday, though. Right? Go back. Okay. Good afternoon, Nightshade dude. Does that mean you're a afternoon shade dude? Or is there someone else kind of wandering around on Twitch somewhere named Afternoon Shade Dude? Are you one of many dudes of the shade? Let's see. So all of this is inside one else, right? So either I put all of this in another function, which I probably should, or I unindent it by doing an early return here. So this is if we're not in vector parsing context. This is where we are. So we have to enumerate through the iterations. And most of it's in this huge match statement where there are multiple ways we could collide. Actually, it's this check on for collision is if it's sum anything, right? And the difference is that if the slot is empty, we fill it in. Yeah, so I can restructure this a little bit. Some child. And then we say if child is none. It's a little bit better. Make sure that nothing breaks when I run this. Nothing broken. It's going to be a lot of that. It's going to be a lot of cleaning up and running the test to make sure I didn't break anything. I think this will be better if I do a few things. At least what I should do is either return OK here. Then reduce the indentation by a level. If not, do the rest of this in another function. Actually, I think I prefer to do it in another function. Yeah, so I'm going to move this to another function. Refactor and extract into function. Add part to composite. Add part to vector. Add vector part? Whoops. I must have hit escape. Add vector part to composite. Actually, do I even need the to composite part? I think I'd just say add part. And this is add vector part. Hey there, Space Barry. Do you have any money? No, that's just a arbitrary. So do I even have a bunny command? Do I have a rabbit command? No. Let's make one. It's just an arbitrary avatar I picked. So add command bunny. The bunny is just a random image chosen years ago for no reason. And then add, was alias com. Dang it. Bunny or rabbit to bunny. There we go. Now it's an alias. It was at one point I wasn't using a camera, that thing right there, that camera. And Mrs. Raymond didn't like the idea of me putting my portrait onto the channel. And I'm not an artist, so I didn't have I couldn't draw anything. So I'm like, I need some kind of avatar. I don't want that silly generic Twitch icon. So I have this picture of a rabbit. Why don't I just use that? It has nothing to do with me or any channel or anything. And Spaceberry, no one's asked me about that since I first started streaming, and that was like 4 or 5 years ago. So I think you deserve some useless internet points for being the first one to ask about that. Let's give you 10 points. 2 points for each year that I went without anyone asking me about it. So why is this returning an option result? How do points work? The points don't work. Points are just like, I don't know, bragging rights? Useless internet points. Hey there, spoof. To Dogecoins, concerned Doge, that'll be a project 3 years from now. We'll write the Raimu coin project, and your points will be converted to Raimu coins. Like, whose line is it points? Yeah, exactly. At one point when I was working on a game, the points were intended to be convertible or used in game for like I don't know, was it vanity stuff or was it just advantaged in playing the game? So it was pay to win. No, it was contribute to the stream to win. But can't work on the game anymore because of job rule number 1. So I had to put that on hold. So I'm trying to figure out what's the overall structure of adding the vector part. Why is there a if let sum return it? I think that this is meaningless. I think we should just cut this part out and just do that. And this should go there. This returns just a result now. And we don't need to return some error. It's just returning an error, right? When this is just okay. Okay, why is it borrowed more than once? Because of the entry? Oh. Yeah, that's a problem. Is the entry only used to get the parent? Because then I have a solution for this problem. Oh, that's also a mutable reference to self. Dang it. Dang it. Let's just undo. Undo the refactoring. Okay. Problem about taking this out to a subfunction is this entry is borrowing from self. And yet we're using self again. So really we can't call another function on self that takes a new borrow until we've used that parent, but we don't use it. We use it all the way through this loop. So it's going to be really hard to refactor that out. The shark is killing you. I'm sorry to hear that, Nightshade dude. All right, can I get rid of these expects? I think I can if I make it something we return out of the match. Because parent iterations get mute is what we're actually getting here. Parents iteration get mute, right? So yes. Option mutable reference to component, no, to optional component. That reduces it to just an option mutable, like mutable option to component, option mutable. Okay, yeah. So I could say parent equals match, and then inside here I do um this is child at some, well, actually I guess I could do child or didn't do none first. No, this is like child slot. This is iteration, isn't it? And that's the slot in the child component in that iteration. So returning iteration dot get as mute. Let's use this trick so I can see the, really? No error there from there? Okay, I think it's this. So when we do that push, we have to repeat, so it'd be parent last iterations last mute. See, again, like I'm gonna have to do an expect here, right? That sucks. So maybe it's just not worth it to do all this junk. Makes the match more complex anyway. So yeah, never mind, we're not gonna do that. Okay. This is filling holes. Part taken, or this is putting in the last, this is getting a child to push in. Okay. I just called it child so that it was a little bit easier to grok that. There's two ways to construct it. We could either take the part we're planning to store, or we're putting a placeholder. Yeah, I think this one I'm going to leave for now. Well, I can't refactor that into a sub function. So I can at least do an early return so I can get rid of one level of indentation. Okay. But that means what I really want to do is this, I guess. That entry. Oh, it goes there, right? I guess we can just say it for the whole thing, right? If not in a vector parsing context, if not parsing in a vector, parsing in the loop, a store part directly. Store part as a child directly in the component. Store part as an immediate child. Okay. We get down here, then we're parsing in a loop. So we have to populate the iteration slots matching the current loop counters, storing the part at the end of the path. So first what are we doing? Oh, that's the root entry in self iterations, right? Well, no, the root entry is in the keyed children of the composite. So that means really I need this comment there. Hey there, Dalek. Parsing in a loop, so we have to, well, it's not that we're parsing in a loop. It's establish the root node for this child of the composite. We're parsing a loop, so we have to populate the iteration slots matching the current loop counter, storing the part at the end of the path. So we take the last step, we take the path starts with the name, we put the part into an option, and we're iterating over the iterations. We're constructing our path as we go. We're seeing if the slot is populated. So slot is populated. It's a collision if we're at the end of the path. Otherwise, make sure the slot. It's not that it's populated. Slot entry exists. Always make sure the slot is populated with the placeholder. Well, it's just populated, right? If it's not the end of the path, it's just a placeholder for yeah, so placeholder for a second level, right? Another level. It's an intermediate level. So here, slot entry doesn't exist. So create any missing entries up to and including this slot. Right, and then if this is the last slot, store the part here. Exactly, that's this part, if it's the last slot. Okay. And I guess we should say here, once we reach here, we should have one way or another. That's why we have these expects, right? Guaranteed that not only is there an entry for this iteration, not only is there an entry for this iteration, but that entry has been populated either with the part or with some placeholder, some intermediate level placeholder. All right, that's why we have these two expects, and then that loops until we've gone through the iteration stack. Okay, so probably there are some people watching who have no clue what I'm doing. So I'm going to illustrate with a couple of unit tests that I wrote yesterday. So unit tests are great because not only do they test that I didn't break anything, they're also sort of documenting in a way what the expectations are and what we're doing. So the whole idea of the tool is that you have some bytes, some like binary data, and you have a description about how to interpret those bytes. And the tool compiles that description into a data structure that it walks through along with the data to tell you what every bit of the data means. So these are all contrived examples, so it doesn't actually mean anything in the real world. Something that would mean something in the real world would be something like this, like a GIF image. Starts with a header, ends with the trailer, has logical screen and data, and overall, this is an image file, right? So it'll contain things like how wide the image is, how tall it is. It's got a color palette, and it's got in the data blocks the actual pixel values, but they're compressed using LZW, which is a compression algorithm. So the tool I'm writing should be able to take every byte of a GIF file and figure out which bytes go into the header, trailer, data blocks, determine things like the width and height, what's the color palette, and extract those data blocks that if we wanted to, we could do a second pass over them to decompress them and then figure out what every pixel of the image was. So back to this contrived example, what we're testing specifically is that I can define data that's inside of a loop. So this means that x is an unsigned integer that's 8 bits wide. But since it's within a loop of 2 iterations, that means in the end we expect to have parsed 2 bytes. This is why I gave it 2 bytes of input, right? So x will technically have 2 values, one for each iteration of the loop. So what the tool is supposed to do is when we enter a loop, we push onto an iteration context stack a loop variable starting at 0, and every time we loop, we increment it by 1, and when we exit the loop, we pop that off the iteration context stack. We use all the numbers in that stack to define a path into this child of foo called x. So since this is just a simple loop of 1 dimension, x will be a 1-dimensional vector, and every slot will be the value that x had in that iteration of the loop, right? So x sub 0 will be 12 hex, x sub 1 will be 34 hex, and that's what this unit test is checking for. So the tool first needs to compile this format into the abstract syntax tree representation of it. Then we construct the input, and we pass the input along with that abstract syntax tree to the tool to say ingest these bits using this tree and start at foo. What we get back should be that it's not an error. Foo is the format. Actually, we don't really need this stuff. I'm going to delete this because it's sort of extra. Foo doesn't have an error. We get an overall value of 34 hex because this return statement is testing that once we've constructed x, we can reference back into it to extract a value out. Also, x exists under foo. It also doesn't have an error, and it has an overall value that is all of its iterations put into a vector. Furthermore, its format is unsigned integer, which is from its format specification there. And there are 2 iterations of it. The first iteration we call x0, no error, it has 12 hex. It also knows that it's an unsigned integer. There are no children, either of x directly or of x0, and x0 knows where in the bit stream it got its bits from and how many bits. So x1 is the same, except for it has the second byte in it. It starts at offset 8. The offset's in bits, so is the limits in bits also. So hopefully that is not too difficult to grasp, because we're going to move on to something more complicated. So this is a more thorough test of this concept of iteration context. So now we have 2 loops. In fact, we have an outer loop for everything, but then we have 2 different inner loops. So that means throughout the process, we're like push one loop variable, push a second one, pop it off, push another one instead, pop it off. You can see x is defined in the context of 1 level of iteration. So x will be a 1-dimensional vector, right? It'll have 2 slots. But we have y here and here under the context of an inner loop. So these will be 2-dimensional vectors. I named them the same to test to make sure that I can do this without collision, because they're in alternate paths. Sorry, it's like just like you have an if statement in a programming language, there's an if statement. It's if statement in the parsing algorithm, right? If it's the first loop, we run this form of the inner loop. Otherwise, we run a different form. And then I do some tricks here. I say this one loops 4 times and this one loops 6 times. And the way this one works is it does nothing the first 2 loops, and then for the second 2 loops, it parses 4 bits. And then for the second outer loop, we only parse 4 times, and each time we only do 2 bits instead of 4. And then it's going to loop 2 more times and do nothing. So we expect that y sub 0 will have 2 holes because we skip the first 2 iterations. So y sub 0 only has populated slots for the third and fourth iterations, these two. And it will have picked up these bits, right, from the original input. Then the second outer loop comes around, we populate x sub 1, and then we go into the second loop, and we populate the first 4 slots. Even though we loop 6 times, we only parsed for the first 4 times, and it gets 2 bits each. And so all of this is just verifying that all of that worked correctly, right? So overall, x will be a one-dimensional vector, y will be a two-dimensional vector with some holes in it. And the individual pieces all remember where they got their bits from. So hopefully that gives you an idea. If I lost you at any point, all right, I want to save it. If I lost you at any point, let me just give you a really top-level idea. So if you've heard of this tool called Wireshark, it's you can download this as an open source tool. I had nothing to do with it. So what it's used for is it captures packets that arrive on your network interface, so your Wi-Fi or whatever, and it captures them as raw bytes, and the tool will parse those bytes to determine where the packets are and what kind of packets they are. And if you select a packet, it'll tell you the details of that packet, because internally it does something similar to my tool. It takes the bytes and it knows the format that the bytes should match, and it assigns meaning to them all iteratively. So I would like to make a similar user interface that has, like, you know, a hex editor kind of thing, but you can drop in a format and then it'll say, oh, well, this area of the bytes means this. Maybe have a tree on the right, hex editor on the left, where we can click in the tree for like different parts of the file, and it would show us on the left like where those bytes are in the file. So that's what we're doing. And I got this working last night, passing all of our unit tests. And I'm just going back today and cleaning up because I had to do a real bad bit of work here. When we get to like indentation levels like past 40 characters, then that means that I need to split up the code or simplify it some way. And if it's hard to split up a function into smaller pieces, I'll at least put comments so that if I'm reading through this a month from now or 5 months from now, I'll have some like clues about what each of these parts does. I'm also looking for opportunities to like simplify. So there were like 2 match arms here that were really the same, and I had this part duplicated. I'm like, I can combine those 2 paths into one path that just has an extra if statement after, and that worked out. Okay, I think I'm going to take this one off. We've refactored that as much as possible, so let's continue. Okay, yeah. I don't think I have a test for this particular place where we get a, what is this? We're determining the limit for something. Oh, we're determining the limit based off of the current context we have, the bit stream that we have, and some expressed limit, like a bound, which could be nothing. So we either have no bound, we have a bound but it's erroneous, we have a bound and it's none, so we return some none, and we have a bound and it's something, not nil, so return some. And then from that value, which is either some, it's just option, we either have no value, so it's none. We have a value, but we can't be coerced to use size, return early. Or it can be coerced, so it's some okay. And then, so that should be option result, or option, okay. So it's not some okay, right? So it's just some uint, usize. So we either get some usize or none. It's an optional usize, right? So the limit is optional. I think it's this possibility 2, can't be coerced to usize. That's the error that we're possibly returning here. And there's no There's no diagnostic for that, I think, because I didn't print one here. No, actually, I am. Okay, we do have an error returned out. It's a string. We're just not doing anything with it. Yeah, so let me make a test for this. It would be something that can't be coerced to a size. So let's close others. So this would be in ingestion source tests. Is there like a bound, or there's bounds, but that's not the same thing. Maybe under part. Okay, we have bad, here we go. Bad argument, bad format. We can have like bad limit or something. Why not, right? Here we go. Bad limit. Okay, so how do we do this? We don't need a baz. Foo, let's just have a UI called bar and do lulls for the limit. So I'm just doing this for the diagnostic, right? This should return an error for foo. And there should not be a value. There should not be a value for bar. So that should be assert that this is none. I think. Although I can't remember. Do we? I think if we don't, if we can't resolve what that means, then we don't bother making one of these. Actually, that might not be true. Let me run this and see. Yeah, okay, that is not true. So it is something. So it's something, but it doesn't. Right. It's something that whose error flag is set. Yes. Okay. Yeah. So see how this runs and it passes the test, but there's no error diagnostic. That's what I want to see. So we do want to print something. So that's message. And we're doing it as a side effect, right? I don't like how it outdents that by default at first. So it's going to be self.onError, the message, right? Error, invalid digit found in string. Okay, so I think we need more explanation about what we're doing. So that means I'm going to do a format. Unable to parse. The name for this is what? Bound? Part bound? Bound. We'll just call it a bound. All right. Run that test again. Unable to parse bound, invalid digit found in string. And so should we, yeah, okay, this is good enough. It gives me line 3, which is this line. Okay. What if I did like, something that's like not, like, it's like, what if I make it an array? Will it say like it can't coerce from, if vectors cannot be cast to usize? Cool. All right, I'm happy with that. So we're done with that one. Get rid of the to-do. Yay. Next to-do. Needs refactoring. Okay. Finalize components. Right, this had like a weird indentation issue. Okay, well, right away I could say if it's empty, continue, right? Get rid of one level. You want to learn software, but you don't know how to start? Well, if you're here, then, well, there's nothing in my stream title that would have told you this, but I like to program in the Rust programming language. So if you want to learn Rust, there's a good starting point there. It is a more difficult language to learn, though. So yeah, really the first step in learning software is choosing a programming language. And there are a lot to choose from, right? We have Rust, we have C, C++, JavaScript, Java, Pascal, OCaml, Go, Zig. There's like a ton of options. One thing that would help you learn or pick which one to learn would be like what interests you, like what kind of software would be fun for you to do. So maybe you want to get into AI. Well, then like what Nightshade dude just said, Python. It's a good starter, right? A lot of AI stuff is written in Python, machine learning stuff, right? So you could go to like one of the sites on the internet that teaches you about how to do machine learning. You'll inevitably start learning Python or something like that. So yeah, I think those are the first two questions. What do you want to do with software, and what programming language do you think will help you get there? And this answer to the second question might be search online for like what programming languages and other things are typically do you need to know in order to do the first thing. Python's very quick and very powerful because they're all wrapped C libraries. Is that why though? I mean, I guess so. Yeah. Did you implement a Lawler parser? Yes, I did. That's why this is Lollipop up there. I'm using Lollipop. So we describe our grammar with Bacchus-Knorr form grammar rules that generate Rust code. Well, it generates abstract syntax tree nodes in Rust. So a parse statement is a variant of a statement in the abstract syntax tree. The language is that of describing data. So it looks like this. So it's just a sequence of data formats, and a data format is both a compositional structure, and it also has logic in it. So it has loops and if statements and local variables and that kind of thing. And it's all for the purpose of parsing some data as some format. So parse something as a GIF, or parse something as the header to a GIF, right? Lollipop is pretty cool because what you do is you set up a build script for when you run cargo build, and it just goes to their crate and process root. It finds all your Lollipop files and generates Rust code that includes in your crate. Looked on Wikipedia for implementation of Lollipop processes. It looks so difficult. Nowadays, there are libraries to do it for you. The hardest part is constructing the grammar. So, for example, Lollipop didn't let me select operator precedence or associativity, so I had to do it with this sequence of tiered grammar rules. So an expression is an expression tier 11, and a tier 11 has the lowest precedence operator in it, or a shortcut down to the next level, and then the next higher precedence, and then so on, right? So it's best illustrated between levels 3 and 2, right? When you first learn math and you do something like a plus b times c, right? You learn that the multiplication has a higher precedence, which means that you do the b times c first, and then you add a to it. So the way we express this in the grammar is the lower numbered, or the deepest expression grammar rules are for the higher order, higher precedence operators. So that's where divide, multiply, divide, modulo, and multiplier can be found. And then the add would be one level above that, minus and plus, right, for add and subtract. And there's a subtle way that you do operator precedence, which is, do you do the left side or the first side? Do the left or the right first? Like if I had A plus B plus C, do you add A and B first and then add C? Or do you add B and C and then add A to it. It doesn't really matter for add, but let's say I had a divide, right? A divided by B over C is different from A divided by B and then divided by C. So traditionally, these are all left associative, which means you do the left first and then go from left to right. And the way we express it in this grammar is you recurse the same rule on the left, so that if you had A plus B plus C, then this one would be the A plus B because that's also an expression 3. And the right-hand side can't be a B plus C because expression level 2 doesn't let you add. Now, if it's right associative, like right to left, you would just swap these two. You'd have 2 on the left and 3 on the right. And there's a special kind of operator called a non-associative operator, like set membership, where you just put the next lower level down on both sides. So A in B in C doesn't make sense. Did you get a lot of conflicts of building the grammar? I got a few. The biggest one was what I've just been talking about, the rules for expressions, because I built it as one huge EXPR because that's what I had. Because I ported this from another parser generator called Bison, and this is a really old one. And there, I think expression was just a bunch of rules, and so the way you expressed operator precedence and order was when you declared the operators, the order in which you declared them set the precedence, and the declaration symbol told it whether it's left or right or non-associative, right? So Lollipop doesn't have this, and that led to when I just ported the grammar rules straight from here into Lollipop, it completely blew up. It said like, this is all ambiguous, and then I had to look in their manual, and they have a special chapter on this. Not under error recovery, but it's under handling full expressions. Yeah, and they have like what I just explained, they explain it another way. Like this, it's ambiguous because you have two different trees with 2 plus 3 times 4, right? It could be 2 plus 3 times 4, or it could be 2 plus 3 times 4. And they say, well, the solution is to make tiers, and I think they explain it on. See, I don't like their tutorial, but somewhere in here they explain that the solution is to make tiers. Blah 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 blah. Here it goes. Pretty straightforward to express precedence in your grammar by structuring in tiers. So when I saw that, I'm like, okay, I guess that's what we have to do. Oh, I had a few other conflicts when I made mistakes. Like, I think it was in statement. Like one of these, I forgot the semicolon or something, and it led to a really strange conflict. But I just had to keep looking until I saw, oh, there's a missing semicolon. So semicolons and parentheses and brackets, a lot of the times those are not only there to make it easier to read, but it's also it's also used to make the grammar less ambiguous or easier to represent with grammar rules. All right, so I'm still refactoring this. We have the early continue. I think if I pull this out, it might be easier. So this is the just need a name for this. This is extracted values for the iterator. So like extracted vector. But then there's still this weird thing. What if I call this by its type name? So that's component extract value. Oh, that's almost better. I just need to import it. Oh, I imported the wrong thing. It's a data component at this level. Yeah, there we go. This is a little bit better. I think it's good enough. Let's see if I can read this. So for every child in the composites keyed children, and we're getting mutable values because we're going to be extracting a value and storing it while we go. We're skipping it if it's not a vector. If it doesn't have iterations, we skip it. So really, this isn't finalized. Well, I guess it is finalized components, but we can say in here, extract values for all children which were parsed in vector context. Parsed in vector context. Right? So if the child has iterations, if it doesn't, we skip it. So if it does, we're iterating it with mutable access, and at every level of iteration, we if the slot is populated, then we extract a value, and we collect all of those together, and we assign that to be the child's overall value as a vector. Okay, I can read that. Done with that. This comment I think makes sense because if I add more to finalize components, then I would have another comment, and then I might actually just make this another function called like extract child vector values or something. Fix this name. Ingest component calls ingest in context. Yeah, I don't like this name because component, you look at the arguments like there's no component. What it's really doing is ingesting the context that's stored, the composite that's stored in context. So maybe this should just be ingest composite. And then this name is bad too. So can I pick different names based on the relationship? So one calls the other. So it forwards the arguments, it gets back a return scope in order to return it. But in addition to it, it has two side effects: finalize the locals and components, and then returns the composite back out. So this is like not only ingesting bits for the composite, it's then like finalizing it. So it's spitting it out, right? Poop out composite? Digest composite? Yeah, the problem is like this is what actually I would want to call this one. Another problem is sometimes we forward to the composite directly and other times we don't. And we don't because that context is still needed, right? Yeah. And I was going back and forth about whether these elementals here should be, the knowledge of how to ingest them should be on the data component itself or on the context. I think I put it on the data component itself because it's context free. It doesn't actually need the context for any of this. It has all the information it needs. So this ends up ingesting it as something, but before doing that, it updates the context to add the format to the path. Actually, is that right to add the format to the path? Shouldn't it be the name? think that's a bug. I think that it should actually be the name, not the format. So, for example, how would I show this? Another part test. So, like, let's make one that exposes see, I have to rely on a side effect. So this will be like very manufactured for getting a side effect. So what do I want to call this thing? Like bad sub part or something like that. So we'd have like a bar, and in there I'd have a spam. And then I'd have like a bar named, well, let's call it bar, but have the format be like something. Widget. I expect that the error message would say that foo.bar.spam is bad. So we put something, make this an error somehow. How about we just give it an unknown format, like just spam. So I would expect an error on foo and an error on bar, right? But it's the side effect I care about. Okay, so that kind of error doesn't actually use the path, so what does? What uses? Yeah, we're supposed to be using that path, so where do we use it? We only use it there? It's only one place I use it in? Oh, in an error statement. Okay, then I don't need it to test a side effect. I know what to do. I'm gonna move that test then to, I have a special test module for error. There. Yeah, it makes sure that the path is something. Right. So actually, I don't even need to do a special test. I can just, all I need to do is name this something else besides bar. What if I just call it, we call it bar, but the type is widget. I still expect it to say foo.bar, but the format to be widget. So I think this is where it's going to break because it's the path is going to be bad. Yep. It should be foo.bar and we get foo.widget, which is bad because I might have two widgets, one named bar, one named baz or something. Okay, so let's fix that. It was around here, right? Yeah, it was here. I spotted that. I'm like, wait a minute, that's not right. I need the composite's name. Oh, do we not know? We don't know the name at that point? Or at what point do we know the name? Is it self.name? Hold on, let me find it. API boundary, locals, path, so this doesn't have a name? Wait, but how do we know where to store it? Is it one level up from this? Ingest? Okay, now I'm kind of confused. So at some point we have to store it, right? Oh, I think it's in the part statement we have to do that, right? Okay, so that's probably it. We don't have the name at that point. Well, it would be like in here, execute statements. So execute statement, there's a part statement. Yeah, we get this name here, right? What do we do with that name? Then we call add part. So it's only at the end do we do this, right? Okay, that's the problem. I kind of need this name earlier. Well, here's where we actually ingest it. So what if I just give ingest composite a name? Yeah, why don't we just do that? So this would take a name. And we need the name here. Where's... Right, so it's just called from there. Okay, so both of them are going to get a name. So that's going to be some string. Name. And the only thing we're doing with the name is we're adding the name to the path. So that means that it really doesn't need to be a string. It could be a string slice. Okay, and then find all the errors. This might need the name too, right? Oh no, this is at the API level. So at this level, it's the at some I thought the name was... Am I wrong about this? I thought we passed in the name. Yeah, there's a name there, or that's a format. What does that do? Is it just select a format? Oh, it just sets the format. Okay. And then yeah, this. So I think we just take the format out as the name. So that would be component with args, component, format. But what do we do if the format's none? We would get to here. Oh, so it is possible to reach this. So I should have a test for that. Yeah, definitely should have a test for that. So let me do that first before I do this name business. Okay. Context. Yeah, just remove that name for now. Oh, shoot. I undid something by accident. I undid the name of this. Okay. Right. That test I updated it, right? To expect the name foo.bar instead of foo.widget. Okay, but we'll get back to that. I want to first make a test to make sure that that it's that other to do we should have done first. Yeah, so it is possible to reach that right now. But we want to actually catch this much earlier than this. So yeah, test first. So that would be at the API level, right? Do I have an API test? Well, I guess I could put it anywhere. I can put it here. So like test bad format. Well, I already have a bad format. That's a bad format for a part. So let's do another bad format test. This is bad format and bad format composite. And this is bad format part. So in this one, I could just return 42. But we'll say bar instead of foo. So when we ingest as foo, we should get that there's an error. Okay, so let's run this test. And it doesn't even compile. Oh, right, I was in the middle of writing that. Okay, go back. Bad format. Bad format composite. Unknown format foo. So that's what the thing I thought was unreachable, right? No, that's not it. Okay, then where's that being caught? Unknown format. Here. Oh, maybe it is unreachable. Well, how did we end up past? Oh, wait. I know what I did wrong. That's if we violate the API. So there are actually three things we could do wrong in the in this. We could have no format. This is test no format. So that could just be foo, it doesn't matter, right? But I can't use this ingest function. I have to actually do this myself here. Let data equal that. So this is bits. And it's this, instead of using new format, if we do new unformatted, right? New, I don't have a new unformatted. Well, this doesn't make sense. So I guess we just do a new. There's no new. Constructor that makes sense. One that takes, oh, I see. I actually don't have a constructor that works. That's why this, well, the whole thing is public, right? So that means I can just make one. Yeah, the whole point is that this is publicly constructible. So I could just make one here and just fill the fields myself. False. So here's where I'm going to put none. Hash map new. Origin. I guess it doesn't even need bits, right? I hate it when I accidentally undo and then type something and I can't redo. We don't need an origin. Oh, that's none. That's none also. And that's an empty vector. Okay. All right, here we go. No format. Format needed. There we go. That's where I thought it would be impossible to get to. Okay, so let's, because I want a name based off of the format earlier than this, I think we'll catch this earlier. Provided argument. Oh, that's right. It could be none for, okay. So maybe it is possible to reach this. But I'm going to have a check further up. So what if I just look at the call hierarchy here? Okay, there the format is the name. And we're putting it in the data component there. Here in jest, that is called by all these tests directly. Okay, this is the API level. Okay, at the API level, we could do the check there. This is a part statement, right? So this will have a format. It has to have a format. So that's in build part, right? Build part. Right here, format. Okay, then all of these paths have a format. Then does build part consume the statement? No, it just borrows it. Okay, so we could use the statement. Okay, then I'm gonna make this one require a format and this one also require a format. We can do a slice, right? So then that's a string. So yeah, this goes to this. I don't need this. Okay. Actually, let me take that error because well, no, I don't need it. Let's reduce that. Okay, and then that goes here. Format and the arguments. Okay, so basically all of the things that call that need to know the format. So this needs to know the format. So that is name. Okay. This one's also easy because that's statement.format. And then this one's a little harder. This one we have to make sure that they put a format into the data component. I guess we just evaluate up here. Let some format equal component with args component.format as string. Well, borrowed. Else. And format, right? It'd actually be convenient to do it down here when we actually have a context, so I can leverage the context to do that. So that's what I'm going to do. Then I have to, okay, I have to do a little, I have to create the context first. Then do that, and then say that's context dot. Okay, then I can say context dot on error. The message is cannot parse without a format. And then component with args dot error component dot error equals true. Return component with args dot component. Mutable. Moved value. I didn't mean to move it. Oh, it should be context. This should be context dot composite. There we go. Let's clone it. Actually, I can just say if it's none. Right? If this is none, do that. And this format we just grab from here. Well, I can do this, right? Or is this going to be a problem? Oh no, it needs a definite format. Okay, never mind. Go back. We'll just clone it out. So we need to clone. And then this is borrow. Okay, I did it. Okay. So going back to parts test, this should work now, right? Cannot parse without a format. It passed. Bad format composite, unknown format foo, and bad part, unknown format bar. Okay, cool. Cleared that up. So now the test error with the value, right? So that's the other to do. I haven't done yet. Now that we actually have a name, where was it that happened in? I deleted it. It was when I was looking at this code, right? Yeah. It was somewhere around here. This one, that was when the path is added, right? This one. We don't want to add the format to the path. We want to add the name to the path. So I need, in addition to the format, I need a name. Well, I guess We don't want to clone it unless we need to, right? Add to path. No, actually, it only needs a string. Never mind. All right, so a name. Please give me name. Because this doesn't have, it just doesn't have a definite format and it doesn't have a name. So we need a definite format and a name. All right. Okay, here I think the name we give it is the format. So the format is given twice. Here we have the name, and we also need the format. And that's the name and the format are the same again. They're just both the name. Okay. Yeah, okay, we're good. Next. All right, so here it's a parse statement. So we get a name, and that's right here. It's an option string. Oh, we have to have a name though. I guess we do a name or format, right? So name dot or unwrap or statement format. Creates reference is immediately dereferenced by the compiler, so I don't need the name one in front. Okay, fine. And that did it. That pass. Hey, look at that, it passed. Cool. All right. Next to do. Now that I've been mucking around here long enough, can I think of a better name for this? This should be like ingest and finalize composite. Because this ingesting context is called from somewhere else, right? No, it's only called from there. Well, maybe I just... Was there a reason? There was a reason why I had to split this up, right? Is there a reason I had to split that up? Maybe there isn't anymore, because I don't see anything else calling it. I think originally I had the split. I had this split up originally, but it doesn't need to be. Yeah, why don't I just merge these? So it's just that. Well, this is outside and goes first. Semicolon. Yeah, then I don't need this. So then this could be shortened again, ingest composite. Okay, and this is just, I refactored out that part. So really it's should be ingest composite as custom. Only it doesn't finalize, so let me undo that one. So I think this is fine. Ingest composite. Just as custom. Okay, I'm good with that. Let's move on. I'm gonna punt on that one. Okay, if a function triggered hit an error, shouldn't the composite be marked as erroneous? So I think so. So the function, let's have like bad function call or something. Function error. So foo calls bar and bar does an error. Lulls. Compile format, so foo should have an error. Furthermore, foo should not have a value. Okay. Yeah, we get the error lulls, but the foo is not marked as having an error. Okay, so let's fix it. Evaluate function, right? We do ingest the composite and we're throwing away that composite, right? That data error. So if data.error self.composite.error equals true. I don't want to turn this flag off if that is off, though. Oh. Oh, I know. We will turn this into a result. So if it's an error, then yeah. Error. So that's an else then. And it's the caller of this that checks that, right? Find call hierarchy, which gets called by a bunch of things. I'm wondering, are we going to actually get a diagnostic out of this? I don't think it will. I think we'll pass the test, but we're not going to actually have a correct diagnostic. Okay, well that's because we're actually printing an error message. But if we did an error in here, so I think that's what I should do. I should do an error. So some kind of thing like, actually, if I just tried to parse bits, right? And drop them on the floor, this should fail because there's no bitstream. Cannot set bounds without bitstream. But it doesn't say where, right? Yeah, so that's the problem. Actually, that's two problems. We get an error, but we don't know that it was while we were in foo. So I think we need two diagnostics there, and that's two problems. So the outer one would be forget where that was. Yeah, where was that again? Well, it would be a statement, right? No, it would be an expression. It's a kind of expression. Evaluate function, there it is. Yeah, I think here we need a diagnostic, like function failed. So self.on error format function call failed. Actually, it would be nice to see the whole path. So let's say call failed name. I could even print the args. Why not, right? Because the args are not printable. But if I did a little trick and put it into a vector, it would be printable. Data value vector args. A cheap trick. That goes there. Moved value. Where do we move it? Oh, we moved it into ingest. Okay, so we don't have the arguments available anymore. Oh well. Too bad. Okay, we get two diagnostics. The second one actually says call failed bar. Actually, we already know it's going to be bar. Let me reword that. I don't like the way that was worded. Call to bar failed. Call to bar failed. Okay. All right. So this cannot set bounds. We need that to be a proper diagnostic. Yep. So I need to do that right here. There, proper bitstream or proper diagnostic. There we go. Now we know that the first error is on line 6, which is here. Cannot send bounds on the bitstream. Call to bar failed. Looking good. All right, moving on. To-dos. Still think I might not need to do that. Needs refactoring. All right. I think one thing we can do is just say key values equals this. That's one thing I can do to like not indent so much. Can I like put that in there and get rid of that? I can. It looks weird though. Like the indenting on that is weird. I don't like how it indents that. Can I just say key value here? No. I think all I really need to do is move this into another method of context. Yeah, so let's refactor this out. So this is like evaluate key value. Was there really a tuple with two options in it? I guess it is, right? Because that's what this map uses. Yeah, option to option. Soon it'll be time to evaluate whether I should actually make it option data value or if data value should have a nil variant. More and more I'm thinking that this would be a lot cleaner if nil was just a variant of data value. Because keeping it out with option is really expensive in terms of cognitive load. Cool, I think we did it. This might not be the best place for that function though. Yeah, why don't I move it up to the other evaluates? Actually, it's the other values need to move themselves. And they're completely out of order. It's like I have this in reverse order. So evaluate expression comes alphabetically first. Then evaluate function, then evaluate key value. And then construct maps, construct. Okay, yeah, this is, I just move this down. I move the other one up. Done. Do I need the self here? I do, because we're evaluating. Okay, I'm happy with this. Moving on. Oh, can I punt on this one for now? This one's scary. This one's super scary. I'm gonna skip this one for now. Dereference mute. It's a little bit better. I'm skipping it for now still though. Okay, let me consider this one. Make a function wrapper that turns an error with diagnostic string into a return scope with side effect of marking the composite as erroneous. I think it's because this used to do a diagnostic, but now that got pushed into here. Oh, it's just a wrapper for require existing. Yeah, these internally do diagnostics. But maybe they shouldn't. Because then I wouldn't have this big problem, right? If instead they just formatted an error and returned it. Yeah. Okay. Then this would be valid again. Because if I caught an error with an error string, then I'm doing the same, I would end up doing the same thing here that I'm doing here. And here. And here. I'm wondering, should I have this function be erroneous as well? All the way up to execute statement? It would have the benefit of not needing to store current statement span, actually. That would be nice if I didn't have to store the current statement span, if all diagnostics were really reported in one place. Well, that would mean that I could only have one diagnostic per statement. But I think that's fine. So yeah, where this current statement span, right? It's used. Why come it can't find it? Here, can you find it now? Oh, final references. That's what I meant to do. Yeah, it's used here, but I don't want to have to use it there because that was a problem. But I can get rid of this. I can avoid that completely. Yeah, and I wouldn't need to do this business. It's all to do these diagnostics. How on warning, where do I do that one? Oh. Okay, so we do need this statement span in there for warnings. Okay. Okay, well then I need to keep it then. But I could still like wherever I'm returning an error like this, I don't need to do the diagnostic directly. I could just do the format, and then if I made the error a string, like for example, this one is called by this, instead of doing an is error and doing all this, this could just return an error. And again, this could return an error, and then refactor this somehow. Yeah, the return scope would only be used if it wasn't an error. I'm just thinking, I wanted that extra diagnostic there, right? So that just be like an extra thing before we return. If it's an error, then return error, then otherwise just return the result. Maybe. Yeah, I think this inevitably all goes up to this all ends up all the way up to this is a value expression, right? These statement executions, right? This will change a lot though if I have to handle errors. It would clean things up though, right? Because I wouldn't have to handle this. I'd just do a question mark there. Okay, this seems like a major refactoring. Maybe I want to skip it for the moment and do it, come back and do this later. So this means major refactoring. Oh, this one was hard. I think I need to do that on a after I've taken a break or something. Okay, I can do this one. This one's easier. This one, I say return it, right? Then that. And why am I doing this value and then self value equals value clone value thing? Because we keep a copy. Why are we returning an option though? Can't I just get it from the value afterwards? I guess it's just for convenience? Yeah, it's just for convenience because the outer uses it. Okay. So that makes sense then. It's extract value and copy. Well, I guess extract. set value and extract a copy. I don't know. That's fine. It's fine. I don't need to mess with this too much. But I do want to split this up. I think this is easier to read if we do values here. And I just noticed that that name is too close to the other name, so maybe we rename it. Iterations. Iteration values. Yeah, that's better. Oh, and this can just be component extract value. There we go, shorter. Okay. Done. I think I'm going to take a break soon. I need to get some coffee. Yeah, I'm punting on these for now. I probably won't ever use this expected field of their unrecognized token. So that's like when we hit a token we didn't expect, we say what that token is and where, and then we also get this like whole list of like 16 things that would be expected in that place. I think that's just like extra information we don't need. So how do I want to remember that, I guess parser generator gives us a whole list of tokens that would be accepted, but refers to them using the strings from the grammar rather than so let's turn this to do into, we also get an expected field of we're also getting an expected field of blank, but this is extra information we don't need. The parser generator gives us a whole list of tokens that would be accepted, but it refers to them using the strings from the grammar rather than using the token type. Yeah, I'll just leave it like that. Okay, and I made this right joined thing at one point, and it was to like get rid of this having to have this first, and if not first, print a comma. But the reason I couldn't use it here is because you're using print, right? And right joined works with something else. It works with a formatter. Hold on, I just noticed we're not using it anywhere. We are using it. How come the search didn't find it? Shouldn't that have been found with this search? Why is it only found in 2 files? Oh, I am ignoring AST. Well, that would rewrite. Why am I ignoring AST? I don't know. It should only be ignoring like the things we built and some of our third-party stuff. So this works with anything that can be formatted. It works with anything that can be turned into a iterator. Yeah, something that can be turned into an iterator of items of T. Okay. So given that, I wish I could like permanently ignore those ones. So I can't use the right joined because this does print. So I don't have a formatter. But if print is a front end for a write, it's not. It talks about write in here. No, it talks about format. Yeah, I think that's the problem. This is using a different macro, and you can't do a write that goes to the same place as a print because print goes to IO print. This does do format args though. So that's going to allocate memory, right? Yeah, that's right. We could do this lock, standard IO lock, and then we could do a write. So that's what I wanted to do, I think. So that's, and it says to do that in general here, right? So we could get standard IO, and then, how do they say to use it? Then write through the lock. Okay, so I want to call this standard IO out. And then this would be write line, right? Standard out. Must implement IO write. Method not found. We could use standard IO write. Okay. Use standard IO write. Fixed. We have to do how does this actually avoid me having to get a result? It just doesn't unwrap. I hate doing unwraps. Guess we're doing it. Okay, so that means all these prints change to write. Go word over. No, that didn't work. Standard out, comma. And then go to the end, unwrap. Hate having to unwrap. Oh well, it's what it is. Okay, so what's print statements do? Ah, this eventually does a print line, right? Okay, well, we don't, these can, actually, we have it locked, so this will be a problem. If I try it, it'll just lock itself, right? How do I test that? So that's cargo, run, bin, parse, stage, gif.format. This will deadlock or with some panic, right? Because I have standard out locked. It's been a while since I built it. Hi there, TBS CHNEIDER. I don't know how to pronounce your name. TBS, how you doing? What did it do? I don't know. I don't know. Let me hit undo for a while first. Try this before I did any of my changes, right? Semi-unexpected. Okay, so that's interesting. Did I put an extra semicolon in the format by mistake on line 28? Oh, is this extra? Huh. Plus unexpected on line 85. Oh yeah, look at that. That should just be a plus. And we're calling this look ahead, right? Right. See, I changed my grammar a bit. 103, another one of these things. So this we're just calling look. Why am I storing it in look ahead? Can I do that? I don't remember if I can do that. Oh wait, why am I doing that? Oh, because it could be changed. Yeah, so that's a plus. I don't know if I can override a parameter like that. I should be allowed to. Actually, that's something I should test. Can I override a parameter? Okay, so that parses it. So now the question is, if I go back to parse, the main of parse, can I redo and like, is it going to be all locked up when I run this? No, it works. Okay, cool. I was worried that like locking standard out like that would mean I couldn't do the print inside of the print line inside of print statement, but it lets me do it. So then I can refactor this. I can just say write joined standard out comma format dot arguments with a comma dot unwrap. Actually, does it unwrap it? I forget. It doesn't work with that. What? Oh, is that the problem I ran into earlier? That a standard out lock doesn't work as a formatter? Can I get a formatter from it? Write format. Not exactly what I want. Yeah, this isn't gonna work, is it? TB Snyder, okay. How are you doing, TB Snyder? Refactories is right. I want to do that, but this type is wrong. How does this work? It's a macro that ends up calling write format. Okay. So I think that means that this write join, I need another variety of it that takes a writer. Ah. It's just not, this isn't suitable to use with a writer. It's used with a formatter. So I mean, I can make another version of this that works with a writer. So like I could do this, write join. It's just that I like that name. Now I have to have a different name to writer. So instead of one of these, it's what? It's like a writer. Um, whatever write FMT takes. Standard format write. Standard format write. So that's guess I'll just use W. Well, no, I'm not going to fall for that. I'm going to say W is a standard format write. Writer is that. Okay, and then yeah, then we turn this around and it's writer dot write string, and then writer dot write format, and then this. That is fallible, right? So I can do that. Yes. Wait, it doesn't let me do that? Arguments. What? Arguments. Oh, right. It's supposed to be, yeah. We can put the writer in there. I thought. Is it just that it has to be mutable? Yes. Actually, probably want this to be a mutable reference, right? Okay, so now can I use this from my main here? Yes. No. Shoot. What is that? I have to borrow there? And I can't do that because write is not satisfied. I thought that's the whole point of getting one of those is to satisfy write. How is it that it works with this? Accepts a writer. Format write. Or the IO write. Okay, I thought so that's what that was. I thought this thing could be. Is it that it's an IO write and not a format write? That's probably what it is, right? So let's try like form write joined to IO, and then this would be an IO write. Oh, is it just write? That's a buffer though. I guess what I just do is do a write writer, write. Can I like write a string slice to it? I can't do that directly. Okay, what does IO write let me do? Flush and write. Write all, write format. Okay, fine. We'll just write separator. It's infallible, I guess. And oh, it has a result. Then what's the problem with question marking it? The not convertible? Can I convert from form to format error? Ah, maybe I just punt and unwrap this. Oh wait, no. I know what the problem is. This should be IO error. Okay, that'll work. Go to main, and we're good now, right? I can delete all this. Okay. To IO. To IO. Share it. Has a result. Okay, unwrap it. My goodness, this is hard to do. Okay, I think I did it though. Okay, where is that actually used? That's for arguments. So one of these that has arguments. There's an argument. There's no places where I had two arguments, right? It's just one argument. Okay. Okay, well, I did that one. That sucked. I had to name it something different because and the body is largely the same. It's just going using the right, it has to go to the right macro because there's no right slice for IO. And we're using, it's a different kind of error. Instead of a formatter error, it's an IO error. It makes me think I should have just had it all free formatted and then write the whole damn string. Okay, anyway, while I was working on that, that exposed a possible problem, right? Which was what? It was, right, in my format, I was doing something funny that I'm not sure if I support. It was that we get something as an argument and then we parse the look ahead back into that argument. And I don't know if I allow that right now. I should because, no, wait, I should not. This is going to be a problem, right? Do I want to, if I allow that, then that means I allow the changing of an argument. Actually, why shouldn't I allow that? It should be a local anyway. It has no bits. The problem is if I what if I want to after parsing this graphic control block, what if I want to know what the original look ahead was before I overrode it here? Actually, if I did want to know that, then I would parse this as like new look ahead or current look ahead, and then I would have a current look ahead assignment, right? And then I just use current look ahead wherever look ahead is. I just do that, and then I would retain the original argument, and I'd be able to overwrite it because that's a local. So since I know there's a workaround if I want to know the original, I think I will allow that syntax. What does the lexer look like in this project? I'm glad you asked. The lexer is written in logos, or with logos. It's a crate in Rust for creating ridiculously fast lexers. So it's derive logos. It constructs the lexer for you. You tell it like what your white space patterns are, what your tokens are, all with attribute macros, and your symbols and literals, you'd use regexes for capturing and identifying them. And I chose to abstract that away from the parser by creating an intermediate type called token, which is in a different library. And then I have a mapping from logos output to the token, which just copies over the values. Blazingly is better than ridiculously? Is there a blazingly fast lexer somewhere? So yeah, the lexer is really just a huge enum that's annotated, plus some callback functions. And we're also packaging errors a little bit nicer than the default. And I have a silly state machine for parsing escape characters and strings that I probably didn't need. It probably could have had a regex do that, but you know what they say about regular expressions, right? You start with one problem, and then someone says, oh, I know how to solve that problem. We'll use regular expressions. Now you have two problems. So yeah, Lexer's pretty sweet. Yeah, I want to allow, if I want to allow that, I need to have a test for that. So that would be in like locals or look ahead. Part? Do I have a part? I do have a look ahead. What's this ignore and reuse local? Oh, right. That we can reuse the local. Okay. So I think we do want to go, I do want to put it here, right? Yeah. So we have a look ahead of X, and I want to be able to like reassign X. Yes, so at the end, there should be no X because it's a look ahead. Oh, wait a minute. No, I wanted a look ahead be able to reassign a function argument. So that would be like if we did a look ahead here in bar. So if I did like a look ahead UI and put it into bits, actually that would be a bad idea. Let me make a new, let's make a new contrived example. So this is function argument reassignment or assign, well, change function argument. Blazing is now a meme because of the Primogen? Is it? Does the Primogen create memes now? It's like internet godhood when you're able to create memes. Okay, so I want to like... Yeah, I want to say like bits equals, like override this. So like, let's say we say there's some bar X and we say 4, but it actually overrides it to 8. Why do I this is unnecessary, right? I can just say return. Oh no, I want to do that. Return content. Yes, yes. So this is change function argument or override function argument or something. So yeah, I should get the full byte out. The offset of the bit stream should be 8. The value of, there is no Y. Why do I have a Y? Oh, I see. I don't care about that. Delete that. So it was before that we returned X, and now I'm returning... We don't need X, right? I can just say bar. Return bar. So it should also be the same value. I don't care about that though. Let's just delete that. I don't need that. I don't need this. I don't care about that. Okay, so it's that when we parse foo, it's not an error. Foo's, well, actually, I do want to see the value come out. Well, then should be able to reach in and get it, right? Return bar.content. It should be that. Okay, let's run this. Aha, it doesn't work. Bits is not local. Okay. Yeah, but I want to allow that because I think it's useful to override arguments because that could be some kind of default that then we determine. Actually, there's another thing. I want the arguments to be. I want it to be possible to look at the arguments like later, right? So I want to have this to be 8 when I look at it again. So it'd be foo.keyChildren.get bar.bits, right? So bar unwrap get keyed children again, get bits unwrap value. I need to make an easier way to do this, like dereference or something. Actually, there's an easier way to do this. I can just make an array formed by bar content and bar.bits. That's easier. Because now we're manufactured a vector. Oh, I needed to make that coffee, didn't I? Vector, vec. Okay, so we get the bits out, and then the other one should be an 8 because we overwrite it, right? Okay. So I think the rule should be we should allow reassignment of a non-local as long as it has no bitstream. So do I have a test for overriding it if we parse it, right? Somewhere? I can just add another one. There's no harm in that. So this would be like change part. So this would be like if we had UI bar 4, and then I tried to say bar equals 8 or something. It doesn't actually matter if I return not. That should be an error. Assert error. And actually, bar should have a value of whatever the first 4 bits are. Foo dot keyed children dot get bar unwrap value. The offset will be 4 because we successfully parsed. So we hit the error on this line, basically. This should already tell me that this should already pass. Yeah, passes, bar is not local on this line, right? Okay, but it should, I want to allow this one because that isn't parsed from anything. It's a value that we only retain because it's an argument that we want to retain. Okay, then I have the test I want. So is not local. We're changing this, right? This thing. So it's that it's found in the list of locals, right? So I think the other the what I really want here is not that it's local, it's that it has no origin. So if this is the first step, it must have no origin in the bitstream. So that would be that means I have to look it up, right? I have to look it up in part. Oh, we actually get it here, entry. So it's entry dot get dot origin is some. So if we're on the first step and there's some origin to it, then okay, this should say has an origin. Has an origin. All right, so back to the test. Here, run it. Cool, passes. This one should now have a different diagnostic. Bar has an origin. Nice. So that when I see that error message, it'll remind me, oh, this assignment is illegal because bar has an origin. It actually comes from the bitstream. If I wanted to, I would say like x equals bar first, and then I could do x equals 8. And that's allowed because we're allowed to copy the value extracted from something parsed, and then we can reassign it however we want because it's a local. Okay, I'm cool with that. So I think it's time to make coffee. Cargo next test run. As long as I pass all my tests, I think we're good to make coffee and come back. No, we have some errors. Okay. Negative I to I. How do we break that? Oh, we said ignore. Yeah, we can't do that. Why did it do an ignore? Oh, we allowed ignored things. Oh shoot. I broke it because okay, I wanted to be able to modify the value. Okay, well I didn't that's silly. Why ignore it and then use its value? So we don't want to ignore it. But I don't need this test. Who cares? We're really testing as we can do um we can accumulate to a negative. So why am I even bothering to parse then? Why don't I just say x equals 42 positive? Yeah, I think that was just a badly written test. So it looks like I did the same thing and I copied that around, right? Yeah, so this should be like x equals 40 um signed integer, right? X equals signed 42. Then why is it s to I? Oh, signed to no, that should be string. Wait. Oh, right, because we're adding a string. Never mind. Um, parsable stui. Okay, so that's just x equals unsigned 42. I guess I can leave that in there. Well, it's just reinforcing that it's a local, but I don't really care. Let's just delete that. Like, why test extra stuff that's irrelevant, right? Parsable st. What about did this have an? Yeah, I don't care about that. Positive I. Okay. Tui. All right. Same thing, right? 42 x equals 42. Delete that one. Positive I to I. That one. Okay, yeah, again, this is an integer. X equals plus 42. We don't care about X. All right. Test UI to I. X equals positive 42. Actually, yeah, and in all of these, I don't need this byte anymore, right? Did that in a lot of tests. Wait, this should fail too, right? Yeah, this is accumulate, right? Let's just get rid of all of the bytes from all of these tests and just say that that equals 42. Adding lulls to 42 won't work. Negative I to I. Yeah, remove that. Don't care. Another one, x equals positive 42. Just all these different combinations of accumulation that, yeah, I don't care about. Yeah, okay, we're looking good. Okay, fix them all. Cool, coffee time. Hey there, A squared. Did you just get here, A squared? Mr. VIP? I need to get some coffee. Be a coffee break for me. But I've been wrapping up and recycling, or not recycling, refactoring. So I'm using wrong words now because my brain is becoming mush once again. Hitting all these to-dos in the code. So after coffee break, I'm gonna come back here, and I think I'm gonna do this major refactoring of plumbing through actual return with like with an error type, instead of just having a return scope and like doing this stuff, which is all redundant. We'll just plumb it all the way up. A little bit ago, okay. So let me go make coffee, and I'll be back in like a few minutes. Okay, I'll be right back. Share stream. Okay. Coffee in 5 minutes. Using the French press, Pete's Coffee Dark Roast. Hey there. Hi, car robot. Okay, major refactoring gonna happen now, right? So, I think I want to hit all the places where we're referencing composite error. Wow, we have 207 places where we hit the error flag. Yeah, this is gonna be painful. 207 places to refactor. Writing your own programming language in Rust 2, that's cool. You're probably making a code generator, right? So that's the difference between yours and mine probably. Mine's not going to generate code. It's going to decode data. So the programs are actually data descriptions. Hey, why is work pinging me? Oh, okay. Saying that a build process was... Okay, anyway. These look like functions, but they're actually also structures. And the program is really just a recipe on how to parse data. So this is a GIF image or GIF image, right? Has a header and a trailer in it. We have loops in there to form vectors. So data ends up being a vector of data blocks. And we have other things like look-aheads, and we have conditional logic. So you're using LLVM for your backend. The backend for mine is custom. We're just looking at part of it. So instead of LLVM, I have this ingestion library. And it's basically parsing binary data using that recipe. How come I can't go forward? There, fixed it. So like, here's what a GIF file looks like, right? GIF 89A. So when we parse GIF, we go to the header. The header has a string signature, 24 bits long. So these are part statements. When we're executing these as if it was a function, we're traversing a data structure in order, right? We're starting at the root. We go down one branch to header. Header has a leaf node called it's a parse statement, which says parse the next 24 bits as a string. So that matches those 3 bytes, right? And then make sure it's GIF, then parse the next 24 bits as a string, and has to be one of those strings. So that's these 3, right? And so on. And it does that recursively until the whole file is parsed. What's that hex editor view? It's just built into, no, it's not built in. Sorry, it's an extension. It's one of these. Hex editor by Microsoft. Microsoft does make some interesting things. 3.5 stars. In the end, I'm going to try to make my own version of this that has the bytes on one side, and then on the other side, we'll have like a tree view where it kind of like is the breakdown of how we decode it. It's if you're making your own programming language, then your language is probably as complex or more than mine. The difference is the execution of the program is just decoding this data. The execution of your programs will actually you'll be generating code instead of generating from your abstract syntax tree, you'll be generating code. From my abstract syntax tree, I use it like a recipe to parse data. So yeah, explanation plus plus. That's one of the things that comes with my stream is that I'll over explain things. Besides, I need my coffee. Wait, did my coffee alarm already go off? Yep, it's done. I'll be right back. Awesome. I got 2 cups. I got 2 cups out of that. Oh, thanks for the follow. Come back anytime. If you're curious, like, this isn't the only thing I do on this stream, so I made this keyboard on stream last year. And if I can think of a new hardware software combination project like that, I might. One idea I had was programming an LED board, because some streamers have those, and I think that would be neat. Yeah. So I'm about to embark on this major refactoring here. How many times did I go back and forth with this? Yeah, it's wherever we have, like all over the code now, there's this print an error diagnostic, set the composite in error, and return an error scope. So I think I need to go to, like, I think the very top or bottom of the call hierarchy and just change it, and then that'll trigger errors all throughout the tree. You watched one of my videos? Oh yeah, you watched the Google test? Yep. That one's kind of old now. What a coincidence. Yeah, Raimu8354, and I actually got that name to start with here, and then I was able to get the one without the numbers on it eventually. Yeah, that was years ago. That was when, like, I didn't know Rust, and now whenever I have to use CMake, I kind of have to shake off that disgusted feeling. Speaking of the start of this year, you moved to a nice mechanical one using programmer's Dvorak. Oh, nice. I'm still using Colmac mod DH for the layout. And as you see, like, I have the caps that have no symbols on it, so I just have to know what I'm pressing, which is why I make mistakes a lot. So how do you like Dvorak? What's Dvorak again? The layout? Is that completely different from Colmac? Yeah, that's different. Yeah, that's different. The Q's in the wrong spot. Where's Z? Way over there. Yeah, I don't know about that. Can we show a comparison? Compare Colmac to Dvorak. There we go. So only the A is in the same spot. Right? Everything else just shifted around. I don't think any other key is in the same spot. Well, the M is, but I'm using a layout where the M and the H are flipped anyway. Yeah, the punctuation way up there, that's weird. Okay, Dvorak's weird. I'm using Colmac, but M and H are flipped. And that's not F, is it? F is up here. Wait, why does it say QWERTY? That's not Colmac layout. This is QWERTY. Why are they calling that Colmac? That's not Colmac at all. That's Colmac. It's not QWERTY. I think that's a mistake. But still, like, this is a weird layout to me. Yeah, I'm used to this ARST. Yep. And my M is over here, and H is wait. Down here, yeah, M and H are flipped. And the B is up here with, and G is over where D is, and D is down where V, or right, D. These are all shuffled around, so it's like the mod DH is a little bit different. Sorry, I'm getting a little distracted. Failing using cargo run the code without setting up CMake or cross compiling. Yeah, I think I'm getting spoiled, and I can just do that, and it runs everything. I don't have to worry about a make file or anything. The only thing I had to set up is the cargo toml, and we just say what our dependencies are. It's super nice. CMake is a real pain in the butt. Don't get distracted. Problem is, I streamed like for 6.5 hours last night until like 2:30 in the morning, and then I didn't really sleep as well. I have to like cut myself off at midnight. And I've already gone like 2.5 hours today. So what I'm thinking about doing is changing this to result. If successful, there's a return scope, but if not successful, I'm thinking just keeping it simple and making it a string. And these reason strings are what we return. Yeah, so I might as well change it someplace, so why not change it here, right? Okay, so then what we would do here is we would turn this into return error question mark, because I learned the other day you can take a static string slice and use a try to upcast it to a string, which is super cool. Okay, and let's just expect that this does it for us. So then I don't have to do this else or let okay. I just say let local equals that with a question mark. That's what I want. It's just now this has to do a result with a string. I think the error type should be what we give at the API level, not what I use internally, unless it's useful. In this case, it's not useful. So this is going to be a string all the way. You think it's cursed? I think it's lovely. Oh, the implementation is cursed. Well, that's what you get, right? To get something lovely on the outside, you have to make something cursed on the inside. Okay, yeah, see all this ugliness? I shouldn't have to do this. I should just be able to say, return this. Return an error forged from a format. Then I don't need all this junk. Delete this all. And then, yeah, it's the same thing. Return error that. How much nicer that is. I don't need to refactor anymore. It's beautiful. You know what I just noticed? We never did that to do. So that means I'm missing some code. I should look and see who calls that to see what existing mute. Oh, so if we try to accumulate, decrement, or increment in a vector context, it's going to be broken. Okay, so I need to make that a to-do. Implement will test the probably broken vector context. Actually, wait a minute. Accumulate, decrement, increment aren't allowed to operate on a part. So it doesn't matter if we're in vector context. What about this one? Assignment and for loops. Yeah, those aren't allowed to operate. So okay, never mind. I don't need to change that. Hold on. It's not broken. It's not broken at all because this is only used for locals, right? Yeah, so actually I should make that explicit. This should dereference or existing local mute. And actually, we don't even need to say mute because it's definitely a local, right? As opposed to this one, which is a part. Dereference. No, this one doesn't need to. This one can be a local, but it could also be a part. It's when we get in here, if we have indices, we can descend into them if any. Yeah. But this one is for dereference an existing local and get a mutable reference. Actually, I guess by convention, it's nice to have that mut in there. But I need to emphasize that this only works for locals. Okay, where this won't work is if we try to increment something in a vector. So I take it back again. Test the probably broken assignment, increment, decrement, accumulate, loop next. We'll loop init. Well, loop init, we don't allow that, right? So to an index of a local. That's probably broken right now. All right, that aside, let's go back to what we're doing. What was the cargo test command you used? It was cargo test lib. No. It wasn't lib. Oh, no, it was lib. But I have errors. I think that was it. Cargo test dash lib. Because if you look at the help, it'll say lib will not run doc tests or something like that. Test only the packages library unit tests, so it doesn't test the tests or the doc tests. So that's what I started with, and then someone else told me that you can get this next test. So that's something you can install from crate install. Next test. Rust. Disambiguate. So yeah, this thing. Next test. Yeah. And Exceptional Ryan told me about this one. Because I thought it was exceptionally cool. But yeah, we're broken right now, so we can't do that. So yeah, I'm chasing errors down, right? And getting rid of warnings. Only 7 errors. Oh, we'll have more. Yeah, all of these we expect to do result. Actually, hold on. At this point, we have the span statement. So doesn't it make sense to let the result equal? And then if, well, match result now? The secondary match? That, well, that's not the correct result. So this should be result as a return result. Return scope string. So that's not, that match isn't correct. Okay, if it's okay, it's a return scope. And then return scope, right? Otherwise, it turns into a return scope error. And we're doing self.onError, the message. And we're also going self.composite error equals true. That's where we'll catch these things, I think. And then the callers of execute statement just need to, they don't need to mark the composite as an error anymore. They can just know that it's been done for them. So yeah, all of these should like... Well, we'll get two diagnostics actually. That the for statement um, itself has an error, and the overall for statement has an error. Okay, that's fine. So you execute statements. Yeah, we just return it out and execute statements. Turn scope up. What's going on with my mouse? Don't tell me it's already breaking. This is like a pretty new mouse too. Don't do this to me, mouse. I just got you a couple weeks ago. Yeah, it's having trouble down here. Right there. What's there? Just a bad spot on the, like a worn away spot on the mouse pad. Maybe I just need a new mouse pad. Oh, I hate mouse problems. You know what that means? I should probably just become more independent of mice. Yo, this is my World of Warcraft mouse pad. I didn't want it to go bad. So here's where we turn an error into a next, right? We actually contain errors in a bound statement. We allow it to continue parsing. That's one of the exceptions to this rule. So it's here, this weird thing where we if we get an error, what do we actually do? What do, like, come on, mouse. Stop it. I don't see anything that got, maybe I just got some junk in the, right, and up against the sensor or something. Yeah, by now, by this point, we're supposed to have like dealt with the error. Okay. Go back to here. Okay. I don't want to have to say that. This just figure it out, right? So all of these need to do the same. Yeah, actually, this gives me the opportunity to clean this up, right? So, this scrolls a lot faster if I'm holding down. Huh. Oh, it's the Alt key. It makes it scroll really fast. I'm like, why the heck is it scrolling so fast? Okay, yeah, we get a result at this point. No, we don't. Okay, this says I get a result because build part gives me a result. Oh, okay. So The point was that we want to return an actual component or actual part out of this, right? Instead of, oh no, we still get a return scope. So if we get an error out of build part, we're putting it into a tuple, and what are we doing with it? We're getting a part, and then we're doing that, which we shouldn't need to do. Why are we registering it? Oh, I think this is the error recovery. Yeah. So build part could fail. Then if we're gonna do, if this should always return a part, then maybe this shouldn't return a result after all. Oh, it's because I wanted to have tries in here. But then I have to have this business with the bad limit thing. The reason to hold on to this was, oh, that's ugly. I forgot I did that chunk. That even if we have an error, we want to know where, that's right. I wanted to know where it should have started in the bitstream, because that's useful information. So this is a case where even if there's an error occurs, we want to represent what the part, like where the part would have started. So we put a part in the composition, but we mark it with an error, and we at least fill in its offset. Even if it doesn't have a limit. If the limit is bad, right? If the limit is bad, we end up putting a 0 for the limit, I think. In here, right? Yeah, we put a 0 in there. That was on purpose. I just noticed something. These are flipped from that order. Don't I want to do this? Why did I put, shouldn't I? I think because this was the primary result, and that's secondary. That just remembers if it was erroneous. It's just turned around. Okay, so ultimately we always want to return something. We never return an error, right? What if the arguments are bad? Even if the arguments are bad, we still want a component, right? So I don't want a result here at all. We want to always build the part, but then we're going to want to check that part's error flag before we continue. That's what I want. So this always returns the data with arguments. But the arguments might be bad, so what do we do about that? The Alt F4? Hello. How was your stream? I'm doing a major refactoring of parsing tool right now. Really would help if I saw the call hierarchy of that. Yeah, so that is now always going to return something, but it might have an error in it, which I checked there, yes. Why? And then okay, I'm keeping the arguments separately for what reason? It was because ingest component takes care of it, right? We have these arguments that are separately passed through to ingest as custom because why? Because we get those arguments and then, oh, because we don't know what the formal arguments are until we figure out what the format is. Then we populate its arguments based off of the format by matching them. Well, not that match, but this where we zip them. Zip the formal and actual arguments, yeah. I've been rated, but your raiders are all silent. Are you like spellbound with this like really complicated looking Rust code? It's complicated because I have to refactor it. I'm refactoring it because it's really bad. Calling us bad names, horrible and scary. Why was he mostly sniffly? Did he catch a cold? I'm retiring the... No, I'm writing a new code base in Rust. It's roughly based off of the C code base. And it's not everything I've ever written in C. It's just this tool I'm working on. Okay, a short summary. Working on a tool called DataDisintegrator. Originally wrote it in C and C++. So it's like a general purpose decoder. You write a format for data in a domain-specific language, and then it uses it as a recipe to parse something. So, for example, here's a recipe for a GIF file, right? It looks like a structure and a function at the same time. So it's a data composition. A GIF has a header at the beginning and a trailer at the end, and it has a multiple number of data blocks, right? So that's why in a loop, data will become a vector. Every loop will populate another index. Elemental things like strings, like the header has a string signature at the beginning, 24 bits long, so 3 characters. And then the version is also 3 characters long. So if you look at a typical GIF file, it'll begin with GIF and then have a version number, right? So that's what this is specifying. The header has a signature and a version. So back to the terminology. What I'm working on is really there's 3 parts to it so far. There's the first 2 parts are a compiler to turn. It would be nice if this was right next to that. Right next to that. So my mouse is wigging out right now. There's a compiler, which is there are 2 parts to a compiler, lexer and a parser, but it compiles this into a memory representation of it called an abstract syntax tree. And then we walk that in order against this data to assign values for all these things. So logical screen will have a descriptor, and the descriptor will have a width and height, and those will actually get the values of the actual width and height of the image. The chill stream with BG, it usually is a chill stream, right? What about arrays of 64-byte structures that allow atomic shared memory parallelism with C++? You'll never be able to do that in Rust. You mean like data, what is it? Data-oriented design? I think you're joking, Tinspin. There's no 64-byte atomics on any real-time platform now. Yeah, that's sort of a hard one to do. Now, 64-bit atomics, maybe, but 64-byte sounds pretty aggressive. How many bits is that? That's 64 times 8. Is that 512? Yeah, 512 bits. 512 bits atomically? That's crazy. You need like a 512-bit register. A 512-bit wide bus. Too many bits. Indeed. So yeah, I'd be happy to answer any focus questions, but right now, I'll tell you where I am. I'm in the ingestion library, which uses the AST to break down binary data, and I'm refactoring how errors are handled. Let me give you an example of one kind of error we might run into. So here's an error. The error here is that we said part of foo is bar, parse it 4 bits, unsigned integer, right? Now the error is on the next line, bar equals 8. Why is that an error? Because I don't want values that came from the input to be overwritten by assignment. So it should give us an error saying that bar, it has an origin in the bit stream, and therefore it can't be assigned anything. So the way that error percolates up and is printed out, I'm refactoring that right now. And mostly following the errors that I have here. And my mouse is wigging out and I'm getting sad because of it. All right, what's wrong with this mouse pad? It's not dirty or anything. Maybe it's just too polished now and I need to get another one. What if I don't use a mouse pad? I guess I don't even need the mouse pad. It's using this mouse pad. I like this mouse pad. But maybe I don't need it. Right? If it just works on the table. Just need to make sure the table stays clean now. Yeah, it's something with the mouse pad, I think, not the mouse. We're talking about abstract machines, really? Okay. I think I was talking about this, right? Execute statement is always going to eat any errors for us, right? But we eat it here with this result that we turn into printing a diagnostic, marking the composite as having an error, and saying we're in an error scope return, a return scope error. So actually, this is really result. Hold on, we have, because of these other errors, I have to. No, that's correct, right? Okay, so it knows what it should be. This doesn't this become a result dot unwrap or else? Unwrap or else, right? Returns a contain OK value or computes it from a closure. Yeah, so we're going to compute it. Really, I'm doing this for the side effect of doing this. Message. That's what I really wanted to do, right? Usually what's incorrect is what's undefined, right? Undefined behavior? All right. So because I started changing the return values of some of these functions, like this one is now what I want it to be, and some of them aren't, I need to update the ones that, I need to fix the ones that have the correct result like this, and then I need to go in the other ones that have the wrong result return value and change it. Right, so the problem here, oh, I wanted to make this irrefutable, right? No, build part is irrefutable, right? And we're always going to add it. We're always going to do this stuff. Yes. Well, then how can I return early? I guess we'd never return early. So do I just say that there's always a return scope here? It's never an error? Or can we actually have an error down here? Oh, we can have an error. Yeah, we could fail to return the part. Okay, then this is fallible. But if we get down to the end here, then it's okay. Okay, then that means I can just make these early exit. And same thing with this, right? I can say match on that with a question mark and then remove the OKs and remove the error. Okay. Right, build part is irrefutable. So I don't need to do a map. So we just get data component with, okay, so let's just break this out then. Cut that out and we say let part with args. We always get that out, right? And this is part with args.map. Actually, I don't need a new map, do I? I can just delete that and delete that and put a semicolon on this. Although I have this on wrap or else. I think if this is going to be irrefutable, then I don't need to do this at all, right? So let's just delete this. Okay. So I just need to fix this build part. Right. So we're not doing these anymore, right? No, we are. We have to have a diagnostic, we handle it because we have to handle the error here. So here I have to return one of these. But here we're going to say a data component new error and the format statement format. And we don't have an origin. Well, hold on. Can I just try to get an origin here? I guess if we don't have a bit stream, we have no origin. Makes sense, right? So yeah. I do have this problem, like, if we can't evaluate the arguments, I don't know what to put for arguments for this thing. Maybe we just put an empty list? Right? Okay, we'll just keep that for now. Then moving on. This is just really weird. This structure of this is really weird. I need to fix this. More coffee will help. Okay. Evaluate arguments should... Okay, this needs to turn into a string. That's why it's wrong. So go back, and now this should be okay, right? It's not okay. Oh, because we can't early exit there. Yeah. Okay, why don't I just move this up? Right? And then we say, let okay args. Well, hold on. I have to do a match then, right? Let... Actually, why don't I form this at the beginning if we know we're going to need it? Right? Now we have a component. I can just initialize the origin to none at first. And if we're able to get one, then we can store it there, right? Yeah, this is... Why don't we just interpret this because it's build, we're building. So, where's a constructor that doesn't need an origin? New formatted, new with format, right? It's just new with format. There we go, new with format. Easy. That wants a string, right? So statement format clone. Come on, dude. Oh, some. All right. And then if we get down to here, we can just say that's component, right? Actually, why don't I just build this to begin with and replace the arguments if we get them? Yeah, we have to independently evaluate them, right? Okay, it would be useful to know the origin before we bail on with the args. Okay, so then let's say component with args. Yeah, we'll have an initially empty one because we don't get them until we evaluate the args. Actually, why can't I do that at the beginning? I could do that at the beginning, and then what happens if I get an error? I could just print a diagnostic and then just remember that we have an error. Actually, yeah, let's do it that way. So we do it this way. We figure out the args and we say we'll do an unwrap or. That's what I'll do. This is unwrap or else message. So we have to print a diagnostic for that, right? But we're gonna end up with a vec new. And the message is self on error message. Okay. And then this will be this with its arguments. That there, and that's arguments. Okay. So evaluate the arguments. If we get an error, we need to remember that there's an error. So hold on. So let's make arguments and error vec. We're gonna remember what the error flag should be. And I got a map. Okay, so we have our arguments and our error flag, and then we can update the error flag with this bad limit thing. In fact, I'll just make this mutable to begin with, and then I don't need this bad limit because this will just have a side effect of saying error equals true. And just return the origin. So we just get the origin back. I don't need to do the none, it's just none, which means I could probably simplify this quite a bit, right? Okay, so in this, bound to sum, so this just diagnostic and then error equals true. And okay, cool. It's none then. Yeah, okay, cool. And then this should just be error. So that's component with args dot component, right? And then we just return that. Easy. Okay, let's see if this works. So we're building a arguments list and an error flag by evaluating the arguments. We map that to add a false to it. And if we got an error, we do a diagnostic and then do an error. I'm gonna turn this around. Because this is accumulating, we'll just say that that's false. And then I'm not making a tuple here, I'm just making an arguments. So I don't need this map. And I just return a vec new, and a side effect is error equals true. That's better, right? So at first, okay, assume no error. Arguments is evaluate the arguments, unwrap or else we're going to have an empty vector and we're going to print out the error message, set the error flag. Then we're building the component with args by taking a new component with that format and yeah, like it has a copy of the format stored inside. That's why we had to clone that. Then we move the arguments in. So arguments should be moved in. Then we're setting up a bound. Why are we doing that? I think this I need to turn around. So we're seeing, does the composite have origin? No. If the bound is some, it's an error. Can't set a bound without a bit stream. If we do have an origin, then we make a subset. That's infallible, right? No, that can give us an error back. Okay, and I just ate that error by mistake. Okay, that's a problem. How's that called by? Only that one. Okay, so why don't I just get bit of result? Oh, because I wanted to also get that, but I wanted to know if there was an error. Then, shoot. Does this do a diagnostic if it fails? Yes, it does. Okay, so then, why don't I just... Seems to me like I don't want to, I want to merge this back in here because I want to set that error flag again. Yeah, I messed that up. It's not always an error, is it? It's only an error if result. So yeah, this is result is error, right? But that's sort of clumsy. I guess what I want is I want a side effect. So error, mutable bool, which looks weird. But yeah, why not, right? So we always return an optional. So this one will... So we're just getting the limit then. Then we don't need that. And this is this has a side effect. Error equals true. And then this is the limit. Then we remove this part. How do I set the error through that? Oh, that's the wrong type. Shoot. I guess we're not using this reason. What am I returning? And oh, well, I'm wondering, like, that's a mismatch, right? I don't know what we're doing here, so put a to do. We don't actually need the error value. So maybe this needs further refactoring. I think this is better. And this could even be improved further, right? So how does this work? This should be like unwrap or, right? So this is unwrap or else. Sum 0. There we go. The double transpose flatten option result. Yeah, we don't like those. I'm trying to get rid of these like excessively wrapped things. I'm also trying to establish a convention that if we have a result, I think what I want is if we return a result, then we expect a diagnostic. We expect something to be done with that. So we're passing back what we think that the caller is going to need. And this error type is a code smell because there's no information attached to it, right? So why are we returning a result saying something needs to be done, but then not giving any information about it? I think if we return anything, it should be at least a diagnostic string, if not more information. And that means that internally, the only reason to do another diagnostic would be is if we're giving more, is if we're giving more focused, um, more if we have local information we're not returning out. So yeah, I'm trying to establish these conventions to clean this stuff up. So make bitstream subset. I wanted it to be infallible. So I wanted to reinforce that by not returning any kind of result or error. But we have a side effect that if we couldn't determine a limit, I still want to make a bitstream subset, but the limit will be 0, and we need to indicate that it's erroneous. Actually, I wonder if then should I put? I wonder if I should put like an option in here, and so if there's no limit, it kind of indicates that it's an error. But that's going to force everything to unwrap or 0 that. That's the thing I don't want. Okay, there's a little bit of tension between those two, but think about it. Boo! Hi. All right. Call hierarchy, right? Build part back up here. Yeah, so this just builds an origin now, but it has to let it borrow the error flag. And then I don't set that. And then I don't need to do this. So, this, I don't really need this match anymore, right? This should just be this, and then map it through that. And then unwrap or do that, right? None instead of sum 0. But none means something different. None means that it didn't come from the bitstream. Sum 0 means it should have come from the bitstream, but there were no bits for it. So if anything, it should be a result. But then there's no, I don't want to actually attach the error information into the output like that. Yeah, well, no, I need the option because none means that it was a local variable. Is there a none return? Yes. So determine limit can return none. There could be no limit. It's hard to see because there's a result and an option. Because we do have 4 possibilities. We have no bound, so it's none. We have a bound, but it's erroneous, so it's an error. We could have a bound and it's some or none. So I do flatten that out down to 3 possibilities. It's none, it's an early return, or it's something. Yeah, so it's really 3 possibilities. It's an error, it's some limit, or it's no limit. Do you use C or C++ regularly before you began Rust? Yes, I use it all the time, and I didn't learn it formally, so I had a lot of bad habits. So if you go back to my earlier streams where I'm doing C++, it's really ugly. And I had a few people actually give me like frank feedback about how ugly my code was, but they weren't very diplomatic about it, and it just made me feel bad. And I kind of wish that I could go back in time and say to myself, hey, it's not your fault, but your code is pretty ugly because you have some bad habits. There? Oh, thank you. You went and did it, huh? Oh, yes, that's right. And now I remember someone named Vincent coming back to me, and he said he was a time traveler, but I didn't believe him. But he said my code was bad and I should learn Rust instead. Oh, wait, you're right. How do we ever return none out of here? I think this is wrong now. Um, oh wait, no, you're right. We pick a default. So why do I have an option here? Hold on. I think you're onto something. What does none mean for this? If we have some, or yeah, so this should just be sum here. Make a subset, right? Make a subset. We have an origin. We expect this bitstream subset, so this should not return an option. Yeah. This should be 0. There is no sum. Okay, you're right. Whoop. I finally caught on to it. Limit. Oh, so this we still need a sum here internally, because we have a default self boundary. Yeah, so points. Let's give you a point for that. You now have 3 useless internet points. Wah. This is still telling me that I shouldn't do that. 3, let's go. What can we do? What can we do with those points? We can do absolutely nothing. Maybe maybe in the future the points you'll be able to use them with the bot in some way. I don't know. Some streams that I watch, you can use those points to like trigger sound effects and junk. But I'm not that entertaining. I don't have sound effects. Okay. Call hierarchy, go back to here. Okay. We're still working on this one, right? Or are we good? Actually, I think we're good with build part. Go back up a level. Okay, so we get a part. Then we're coupling it with a return scope because if there's an error, we want to pull the component out with an error. If it's not already an error, then we're making a new context with that component and ingesting it and then pulling it back out. Yeah, this is a little weird, but it's sort of like, actually, I wonder if I could just let new with part do that. If it gets a data component and it has an error, it could just return right away, right? Actually, well, we want to skip ingestion completely. So there's no point to making a context. So this is just avoiding the construction of the context is all, right? This I don't really need, right? I don't need that anymore. There we go. I needed it before because there was more junk around it, but now it's easy to see. Okay. Yes. Okay, so this is a mismatch because add part doesn't have the right result. Okay, so this should just say return error with this format. Okay, it took me a minute there. And that, okay. Same thing here. That goes there, delete, delete. Cool. Call hierarchy, go back up 1. Actually, that wasn't where I was. Was I here or was I here? I don't remember. I think I was there. Well, no, I wasn't here. Okay. I don't know where I was. Aha. Yeah, we're bubbling this up, right? Yes. Same thing here. We're getting rid of this, and the diagnostic if any is coming back up as a result. So yeah, I don't need to do this, do I? This. Oh, I wanted to annotate that really. So it should turn message into a format message and early return it. Yes. Cool. I like that. Then same thing here, right? This goes in here. Nice. Okay, we're getting there. We're getting there. Okay, so it's this one that's not right. Okay, so result string. I should just hit all of these now. Replace it with this. All of these should have that same result type. Major refactoring is what we're doing. Okay, that already had the correct thing. This didn't. Okay. This should be okay. Okay. Right? So this sets it. Here's an explanation of why we don't log anything, call error call if we fail to evaluate the expression. We don't really care about logging an error for a bad expression because the bad expression does that internally. Also, we don't really need to call the error callback. Actually, this is not true anymore. Is it? That might not be true anymore. I need to reevaluate that. So we do okay if we don't need to do the diagnostic, if we don't have an error message. Yeah, so that makes sense because we have nothing to report as far as the message there. These other ones do though. Alt plus level and navigate back in cursor history. Yeah, that's what this does. For me, it's I rerouted it to command control left. Command control left. It's weird combination of my keyboard and being in a Linux virtual machine on a Mac. It makes things really interesting. Okay, populate composite arc. So this should be string, right? Why does this just have a error side effect? How does this work? Oh, do we want to? I think I do want. Okay, I need to determine where do we stop the errors. We should stop them at the statement level, right? Okay, I'll be right back. I need to go just for a minute. I need to actually put these coffee cups back. I'll be right back. Share stream for a minute. Oh yes, I got it. All right, we chillin'. We got fired. The errors never end. Most of the work here is dealing with errors, right? It makes sense to me that we don't return an error here. Because, okay, so it's below here. So as custom, do we deal with it here? I think the answer is yes. To match these other ones, we do. Because these ones will internally do that. Okay, the other alternative is we clean this up a little bit. Actually, okay. We don't want this to do error directly. So here's our opportunity. So yeah, then I do want this to do an early return, right? What about these finalizing locals though? Then, okay, let's say I change this. What should it be? It should be result return scope string, right? If it's like that, and then we change this to be return error that, which I could turn this around and say, let origin equal that unwrap or, right? Or, yeah, unwrap or. No, I don't even need to do that. It's map error, right? It's okay. Or. Okay, or that question mark. Like that. Why does that not work? What's wrong with that? How to convert a string error to string. Oh, I gotta put that. No. Wait, what? That was working before. Wait, do I have to actually do this? Hold on. Is it because of this? No, it still doesn't like that. Indeed. What if I don't do that? It's a result, right? So what's the result type, though? Is it the correct type? No, it's not. It's a slice. Is it like into and then early return? Type agitation is needed. Blah. It implicitly writes. Oh, is that the problem? So it'd be this then. Thank you. You got a point. Thank you. All right, so if I do that, then this is a result now. So I want to do that always, right? Yes. So then I am going to need to do a an unwrap, right? The result is a return scope. It's going to be unwrap or return scope error with a side effect, right? No, it's just going to be unwrap. Yeah. Unwrap or else message. And then it's going to be return scope error. And then self.onError message. There we go. And then I can also set the composite error flag. Right. Cool. So I just need to do the same thing for all of these. So it's okay or early trend. Actually, I can just copy that, right? Copy. Pasta, change that to an I. Pasta, D. S. All right, and then this result has to be like what we return from all these. All right, I've been talking too much. Streaming too much, talking too much. Cool. So there are some extra errors here, right? Yeah. Good. We can get rid of that. Turn error. Actually, are we allowed to like do this? How do you guys feel about that? Is that a sneaky, or maybe I just do this? I still have to convert it, right? So really, I should do that anyway. Yeah. At some point we oh man. I was talking too much. I'm irritating my throat. We need to clone it into its own string anyway for use later because other paths will format their own strings. So I might as well do it at the source, right? And then just gets moved out through all those paths. So yeah, this just becomes an error question mark. Think it's fine if you have to convert it? Yeah. Okay. Oh, there's two more places. Actually, and that wasn't even caught correctly. We were returning next even though we should return error. Yeah, why are we returning next when we're setting the error flag? Is there a reason I was doing that? Because I don't think that's correct at all. Yeah, this is just wrong. This error. Okay. These are always going to be next, right? So I could just hard code it to be like next if it's an elemental, but I'd rather just keep it there. Okay. Back. Oh, 69 errors. We have 69. Okay, let's copy that. Go back. Paste here. Cool. So this is just this we can just say return error, right? I don't need to translate it. Okay, and this one is really nice because we just do this question mark. Question. Should execute statements also return a result? No, these results are all unwrapped. So here's where we catch them all, right? We catch them here. Okay, then this just becomes like a map, right? Or if it's if it's an error, otherwise, yeah, that's actually what I did. There should be an easier way to do this though, right? Like maybe a match? What's better, a match or an error? It would be a match it, and if it's error, it's error. If it's anything else, it's next. I just don't like the way this looks. I guess we can put an okay around here. I don't like that though. But I could turn it around and say, like, this is the result. Let result return scope equal that. And then we can say, okay, that. I'm okay with that. I just didn't want it to look inside out like it did. Actually, I kind of like the old school way to do this. If I just say if it's not equal to error, it's next. But is that any better? Oh, you can't do a let not equal? Ah, should it would just be let equal else, right? Let me guess. That would consume the yeah, we end up borrowing it or something. Yeah, okay. I'm just going down a path of like silliness at this point. Put it back to where it was and call it. Yeah, let's just gonna move on. Aha. Return error that. Okay. That's it for context. 66 errors. We're in expression. Yeah, so all of these are like string, right? And evaluate expression. Yeah, that just does early return. So then can't I just turn this around and say map it to data value set? So like Get your gay? I can turn this inside out, right? I can just do map values to okay some data value set values. And then delete all the stuff around it, right? Except for that has a problem because it doesn't know the type. Which type does it not know? It's the type that this takes. Oh, no, there's a problem. It's not an iterator. Oh yeah. So sorry. Yeah, it's just a single value, and you can't do a map of a single value. So the way I had it before was correct. I can't make that. I can't improve that. Okay, just leaving it. Who's speaking in the background? Oh, I think my son's yelling while playing Terraria. That's Raimu Spawn yelling in the background. Means I should probably close the door so you don't hear his yelling. All right. Okay, yeah, we have to hit all these expression types, right? String. This is already pretty close. It would have worked. So you can map a single value. Thing is, I was collecting into a B tree set, and then like it doesn't make sense to take a value and then do a map into something else, right? It makes more sense to like just use that as the value for the constructor. Oh, you mean reverse the order? Do the map and then do the question mark? Without the early return, I see. You do a map, if it's successful, into key values. Or wait a minute. This form that I already have is actually nicer, right? Why don't I just use that form down here? Yeah, why don't I just do that? That's easier. So this is what values. Yeah, that's the best, right? Because it's clear we're constructing some values and it might fail. And if we get it, it's that. I guess the reason to turn it around would be we could get rid of the OK, right? Sum is unavoidable because construct set asked for it. Actually, I could push that up by just making that not an option. Yeah, well, but that's to make it more easy to adapt to evaluate expression. Otherwise, I'd have to say a sum around this with a question mark as well. So that's just to meet the match type. Okay, could be avoided. So let's see how it would look. It would be that before we collect, we map key values to some data, this thing. And then collect. Actually, that is the outside. Hold on. How would this work then? I have to collect first and then map. Oh wait, I see. So we don't do the early return. We map it to that, and then they do the early return. Well, I won't even need to early return it anymore, right? I just do this without the semicolon. Iter map collect map again. So what looks better, that or that? We avoid having to say okay there. Actually, you know, I'm kind of okay with that because if I hold down that key, I can see what we're doing. So iterate the key values, we evaluate them. When I read that, I should think that we are forming the type of collection that we need, but it might fail. And the map means if it didn't fail, put it in there. This type is wrong though. This has to be string. Go back. Yeah. Actually, I kind of like that. You're not sure if it would have been more readable? I think it's okay. No pun intended. I love that you can collect an iterative results into a result of collection. Yeah. And the map is like unwrapping it sort of. Well, it's pushing this wrapping into the okay, right? Yes, so then this is this, and then we don't need to do the early return, we just map values to this. Some vector of values. Okay. Dereference does not return the right thing. Unary operation does not return the right thing. Cool, so this does not have to do this. It's just error that. I like it. So I think we're going to end up not needing that error type at all because we're basically eating all the errors, putting them into an error flag in diagnostics, the API doesn't actually have any errors. Yeah, so this is just return error. And I don't have to map the error anymore. Look at that. I got rid of code. Unnecessary code. So that what this is teaching me is that error type that I had is really just at the API level if I need it. Especially because I'm already encoding at every node whether there is an error, because I actually need to retain that information. Can't pass functions to map or only closers. No, you can pass a function to a map. Yeah, exactly what Spoof said. String, so again, return error. Yeah, and then we don't need to do this mapping. Of course, we got to change all of these. Oh, they already are. Okay, cool. So that's nice. We're reducing our errors. We still have 67 errors, really? Where are all of our errors? Reference. Yep. So again, return error that. This also has the advantage of we could do this down in places where we don't have access to the context, and it boils up and gets caught at the right place. Yeah, this is an indentation problem. The fact that it's not formatting these, it's an indentation problem. It will be fixed as soon as we refactor it. Ugly, ugly, ugly. Can we do this in a less ugly way? Sure are a lot of ways we could fail. I should have thought of multi-cursor by now. Okay. Cool. Actually, what's this unwrap or else? Oh, right. That's what this comment means. Copy it at the end of the path. Okay. 55 errors, and we don't need the error type anymore. Statement. Oh boy. Is that because this returns an error? Yeah. So this just becomes let local equal that question mark. And this is error. We didn't like that. Else does not diverge. What? Oh, interesting. It doesn't like that for some reason. Else clause of let else does not diverge. Expected type bang, found type. Oh, interesting. So it thinks that there's actually a way out of that else. Compiler doesn't see that error always returns true. Interesting. A point for participation. And I typed that wrong, and I wish I had history in this stupid client. Or remove question that. Oh, actually, you're right? Because now it's like the type is, yeah, there we go. Sure. Right. One more point for you. Now you have 5 points. So, yeah, isn't this like local value equals this question mark? Yeah, easy. And then, I guess we're doing okay here. Actually, then why am I doing this? Shouldn't that, why don't I just say let value equal that question mark? Delete this stuff. Easy. I like the direction this is going because it's more readable. So the same thing here. Let value equal that. Again, let local equal that. Okay. Actually, a lot of these are going to be the same way, right? So this is error. This is let limit equal that question mark. This is error question mark. I like the flow. Okay. Match if it's okay sum. Okay, so here the error, then I can just do a question mark, remove the okays. It's some value or none. Which means I can say, did I do this right? I don't think I did. Let me fix the other things first. So, okay, that always eats things. So it's gonna mark the component as errored. So we're always saying that this is okay. There's a problem, right? It might continue to execute. I think actually we want to check. But we'll get there. Let me fix it first. Let's do let local value equals local value okay or. Oh, like right up here. true. What looks better? Let local value equals that. Okay, or this. I don't have to say the word error, which is kind of nice. Okay. I think I like it better. Thank you. There we go. I'm getting frustrated with the client I use for Twitch chat. It's the Twitch chat default client, and I'm starting to hate it more and more. I think what it is I'm missing the plugins I had on Windows. So maybe I should move back to Firefox and have the plugins. Might need to be an ASREF, or else you see that, yeah, if it complains. Well, hold on. So local is a mutable reference. We're taking out a reference to its value. I think it's okay because we're local is just carrying on this borrow, right? From, and we're using it temporarily to add the value to it, and then we're done with it and it gets unwound, it gets released because we've turned it into a value, because this returns a new value that's owned, and then we're storing it. I think we're okay. Oh, well, this is returning a new value, right? So by the time that this returns, we've released the reference here. So this is borrowed for the lifetime here through here. Then we own a new copy now, and then we're okay to. You're not sure? I think it's okay. We'll let the borrow checker be the final judge. What was I gonna do here? Yeah, we'll see if it complains exactly. Oh, this we can clean up now. This is return error that. The okay. I think it's just like this okay down here, right? Yeah, it's okay that. But I'm a little hesitant. Let's mark this. Actually, there and there to do this. Does this make the parser continue despite hitting an error? The only place that it's really safe to continue after an error is if we're in the bounded region. I don't think this is actually safe. But then again, if internally this converts it into a return scope error, which does the same thing. It should go all the way back out of the part. Actually, I guess it depends on what do we do for a parse statement. So this is where we ingest a composite, right? And that gives us a return scope, and that tells us if there's an error. In fact, we even unwrap or else there too. Yeah, okay, that's right. Okay, so this reflects it. But is that good enough? I think maybe not. In fact, we have an error here. I think maybe we should, instead of doing this, there should be like another error returned back up. saying like unable to parse something, and then we'll get a chain of it diagnostics saying unable to parse bar, unable to parse foo. Yeah, I think that might be the best idea. So the reflection should be return error format unable to parse. And then what do we put there? The name? Yeah, the name. Do I still have a copy of the name? No, it's been moved, right? Or it's optional. I guess name or format? Oh, it might be nameless. Oh, but at some point where we did a name or format, right? This one. Can I just do that again? Yeah, I guess so. There we go. So that, hopefully that fixed, that addresses the to-do I just wrote. But I do have another problem here. Result, oh yeah, that should be a string, right? In fact, it should always have been a string because that we should never do. Match, so this is just error. This doesn't early return, right? So, but just fine because it's the last statement, it doesn't matter, right? Okay, yeah. I have a feeling like this could be reworked to be if it's a vacant entry. Well, no, that's where we actually need the entry. Well, couldn't it be like is vacant and then either wrap it in an okay or do this other stuff? Yeah. Let me put it to do here because I'm hesitant to do this while we have other compiler errors. Consider refactoring out the match. Because I'm starting to feel like match should be avoided unless there's no better way. Or unless like it clearly improves it in some way. Okay, we're getting there. Down to 26 errors. Right, so it's more of this stuff, right? Let local equal that with a question mark. Match it. If it's none, this is return. Okay, I can do this with a question mark if I remove the semicolon, right? Okay. Another error, right? So this is also an okay or thing, right? This makes me feel good that these could probably be reduced even further with like okay ors. I'll come back to that. Refactor using okay or. Using static strings as errors? No, not always. Sometimes we're formatting. So here's an example one where it's not static. Because this type description is local knowledge that will be lost unless we put it into the string right now. So that here's a case where we have to actually, can I actually do that and do a question mark again? I can. Yeah, so that's a case where we have to pass an own string. The alternative would be to use an error type where this is a one kind of error and then we push that information into the error object. But I'm thinking like really the only thing I'm going to do with it is print a diagnostic, so I might as well just use string and not use an error type. And yeah, hey Greyjack, how are you doing? It's strings for now, but I was having an error object, but I'm convincing myself that any error that I get, I just want a diagnostic for it. And because we're already setting an error flag everywhere that is impacted. And I'm not going to do anything else with that error other than print it. So why not just keep it a string, right? If we have an error, it's a string. Okay, so this is just okay. Error-driven development. See, like all these things are so much nicer said like this, right? And again, this can be reduced to an okay or. So yeah, this is just error. Wonder why Clippy doesn't yell at you for putting all the format arg outside of the. Oh, it probably will. I think it Clippy backs off when you have errors, so it will get back to that. It'll complain. Don't worry. Actually, let's leave it to do. Clippy should complain. All right, so yeah, so we're having is error, right? Yeah, so this is just self add part question mark. Why do I have that assert? Oh, because insert tells me whether it was there or not. And I kind of wanted to check the return value. It should always be true. Okay. 6 errors. Wow, we're almost done. Cool. Oh, this one's super easy, right? It's just that. Self.composite.value equals that question mark, right? Easy. Set insert will be such a great candidate for using an enum instead of a bool. Oh, the thing we were just looking at? Where was that? I don't, okay. Where was that again? It was where I had the assert. So you're saying that this should return an enum rather than a bool flag. It should return an enum like inserted or did not or was not inserted. Yeah, it is a code smell, right? The fact that they have to have it in a comment. If they just return an enum and the enum variants had words that explain that, then they wouldn't need the comment. Yeah, I think we're on the same page. Set insert here should return in enum was present, then they wouldn't need to describe this, right? Well, maybe they'd have to say this part, right? They would say like if was present, so for was present true, no, was present false, maybe this bit, and that's all they'd really have to say. Yep, backwards compatibility, but are we? I guess since 1.0.0. What if Rust supported return overload by return value and you had another insert which returned a different type? And then it would select it based on the context. Well, bool is not inherently bad. It's just that bool only has part of the information, right? It's only one bit of information, but there is actually more information tied to it. It's the implication of what true and false means. And the enum with 2 variants is like a bool with additional information attached. It's like the type itself records the meaning of true and false for in that context. I kind of like the enum using an enum for that. Kind of sucks with bool. I think you're right in that the information is distributed now. You have to go back to the documentation and see what does false mean again? What does true mean? Especially with insert, it's like, does insert true mean that it inserted it? And yeah, actually, is it even consistent? Because I would think insert true would mean that it got inserted. Yeah, so I'm right, but I think that's just by luck that I'm right, right? But someone else could look at that and say, well, I think it should return true if it was already there, right? So it's a little bit open to interpretation, and that's a bad thing because you can get confused. Okay, so then this is just okay then. All right, 2 errors and 2 warnings. I see an error up there. Oh, it didn't like it. Look at that. Cannot move out of local value, which is behind a mutable reference. Yeah, we want an as ref. Yeah, an as ref makes it so we don't borrow it unless it's something, right? So you were right. Who predicted that we'd have a problem there? Vincent, right? And Spoof. Spoof and Vincent both thought it would complain. Points. There you go. Congratulations, you were correct. You seem to be trying to use match for destructuring a single pattern. Consider using if let. Try, actually I had a suggestion to try. Do I dare? No, it can't auto do that. Yeah, this whole thing about that should be if let. Some value equals, get rid of the match, and then an internal match for that. It's still ugly. Here's an example where I'm adding context to a diagnostic. So I have the original reason and I'm wrapping it in a larger reason because we have this local information, the which. Actually, can't I just do this with a map error? And then I should just say if we'll try from, yeah. So I should say let if try from map error then do that. It didn't like that though. Oh, probably because of this return. There we go. If bool try from value, map error reason to that, early return. Does it make sense for the parser to continue despite hitting an error? It doesn't though. Oh, it's if exit. So I need to update this. If execute statements returns return scope error. Does it make sense? Yeah, okay. The Witch of the West, right? Well, we got rid of the witch. No, we didn't get rid of the witch. We're adding the witch to the reason. It's the witch alternative, right? No more errors. Only warnings. Unused origin. Yeah, we never needed it. What did I do with it? I just bound it up into there. So... Right. So it's really a map. If the origin is something, we've mapped it in to make a bitstream subset. Oh wait, no, I needed to do something with it. Shoot. We would break this, right? This has to put it into components with args. .component .origin. That was the whole point of doing that. Yeah. Okay. Glad that that error helped. Yeah. So the Clippy thing, it never warned me. Right? What's wrong with Clippy not warning me about this? Is it because it's multi-line? It should have warned me about that, right? Is it because I don't have, I should turn it on anyway. Although this I'm going to regret this, aren't I? The ingestion source lib turning on pedantic. I don't have it in this project. Oh, what was it? File, new window, file, open recent, rusty keyboard, pedantic. This one. Am I going to regret that for pedantic warnings? How many? Ooh, I did regret it. Look at that, 107 pedantic warnings. Yep, it's a pedantic warning. In fact, there's two of them. Considering adding a semicolon, and the variables can be used directly in the format string. It wants me to put a semicolon there. I guess to make it the same as it's saying that there is no value, so unit. Yeah, well, let's make that a task for another day. Maybe later today, who knows? You will maybe regret uncommenting this. Lulz. All right. So let's see what broke. Okay. I guess we're just picking one that broke and seeing how it broke. So several bounds. This test broke. Unable to parse Y. Skipping one extra bits in end-bounded region. Yeah, actually, that's cool because we're seeing that it can't parse that and it skipped a bit there. It panicked on 49, saying that it couldn't get a Y out. Oh, it didn't store Y because of that error. It couldn't parse it, and so it didn't store it, and so we can't see that it has an error. Okay, so I broke the ability to know that a component would have been parsed, but there was an error. And that's specifically that it couldn't find the origin. It couldn't get a correct origin, right? We got actually it should have said its outer bound exceeds inner bound. So that's another problem. We're missing that diagnostic completely. So let's trace that back. So that was in statement. Execute parse statement. It does a new part. And it takes the, that's not it. Build part, right? It's build part that has a problem. So it'll get down to this origin and it'll try to make one. And it'll go into determine limit. And it should hit this inner bound surpasses outer bound, right? So it should return an error from determine limit. Okay, so it does eat the error. This is wrong. So I think what we need to do is, we're in context, right? This is a message. We should actually do a self dot on error message. Right. And yeah, it's the caller of this has to check that error flag. Okay, we did set the error flag, so is it on the caller of build part? I think it is. No, it should have returned early. Oh, well, that's the problem. It shouldn't return early. We actually wanted to store it. We want it to be registered. What I wanted to do on error is just skip the, oh no, it is doing it. So it should not return early. It should just not do an ingestion. Okay. Ah, that's the problem. Yeah, we want to do that last, right? Yeah. Yeah, we want to do that last. Yeah, they used to continue from here. Now we're returning early. So we want to do that. We already moved the part in, so we'll have to remember that it's so let error equal part error, and then if error. Okay, that's what it is. What's the for? Oh, I can explain what that is. Go back until I find it again. Okay, so this is a special kind of block. It says that this block will consume it should consume no more than 4 bits, right? So what happens is this, by default, UI will just use all the bits it can. So X will be 4-bit integer, right? Then it says, well, this is no more than 1 bit. And so Y will say, well, I want 5 bits. And so it should be an error. Inner bound exceeds outer bound, right? But it should continue parsing because it's like a containment unit. If there's any error inside of that bounded region, it just contains it. The things inside will have error flags set, but foo won't infect foo. Actually, that's not true. It will infect foo, but no, it won't. Actually, that's a good question I just asked myself. Should it infect foo and cause foo to not parse anymore? I think the answer is no, it should continue, but the error flag should propagate up to foo. Which means that the code I just wrote has a problem, right? I need to actually have 2 return scopes, like error and error contained, or something like that. Anyway, when we get to the 2, that means this takes no more than 2 bits. So this is the other possibility. You only need 1 bit, so you have an extra bit. So you get a warning saying that 1 extra bit, and then it skips it. Can you do a clippy fix? Can you? I don't know. I kind of feel hesitant to do that because I don't know. Can you undo a clippy fix without version control? Can for the ones that have a suggestion. Turn nursery limits on? I thought pedantic was the worst you could do. There's nursery? What does that look like? So pedantic gives me 107 warnings. You're saying that there's a nursery? 290. Oh, okay. You will undoubtedly regret uncommenting this. Actually, what's one of the nursery warnings? What do we see? This could be a constant function. Could it? I haven't really started thinking about like should functions be const. But yeah, maybe. That just means that if you had a value of this type at compile time, you could compute that at compile time. Right? It has no runtime side effects. So things with no runtime side effects, right? Yeah, so sure. This pattern can be expressed using what? Equality. Try return scope equals error. Oh, well, that's a nice one. I'm actually liking the nursery. Except for maybe the const function, map or else. If an it... Oh, I remember this one. I didn't agree with this one at the time. Because I think that that looks uglier. Map or else, nil to string, index to string. I think that's easier to read. Yeah, some of these I remember not agreeing with, but I thought they were in pedantic. Maybe they're in pedantic also, and I'm going to end up... So it's let me guess, Clippy fix is the same as me doing the quick fix, right? Yeah, I don't know if I agree with the map or else. Aha, another one. So that one's a useful diagnostic to know of, right? Oh, you can do away with that? Ah, yeah, self. Yeah, yeah, there we go. Okay, I like a lot of these. This is because it's in value, right? So, oh, I can get rid of a lot of the warnings just by saying self. Ooh. Now we're only got 270. Where were we at before? More. Do it more. Self. 262. For my defense, the fill match arms did that for me. It's not my fault. Like when I did fill match arms, it put the word value in there for me. Not my fault. Let me be careful here. Okay, I guess we can do this forever because there's basically over 200 of them. So maybe I stop for now. Lib. Comment that out. Should get back to 0 warnings. That's how we fix our warnings. Oh, that was it. That was the only thing I broke. Okay, but there was the question about in that bounded region. Hopefully that makes sense what this is now. Again, really briefly, this is a bounded region. It says how many bits should be in this region, and you can go under, but you get a warning. If you go over, it's an error. If you meet exactly, then you're good. And it lets you do things like UI, which is very greedy. You don't have to set a bound on it because it just fills up to 4. If you go over, it's an error. If you go under, you get a warning. And what I thought of here was if this will be an error, and it should infect foo with an error, which we make sure it does. But would it stop the parsing if foo is in a higher order thing? And I think it should not, and I think it does right now, which is a bug. So let me construct a test like that. So let's say the test is test error in bound should not stop outer composite parsing. So I need to make two levels here. So let's say a foo has a bar and it has just a flag or something, bit X. And then bar has an erroneous bounded region, right? So this should parse 1 bit, and there should be no error on X, but foo should have an error, right? So I don't know. Looks like it doesn't really matter what I put here, as long as we put something. So I'll just put a 0. Yeah. Actually, maybe let's make that a UI8 to make sure I get the whole byte out. That Y should not eat any bits at all. Okay, so in just foo, we should get 8 for the offset. There should be an error, error for foo. There is an X and a bar, right? We take this one. There. So X does not have an error, but bar does. So X's value is the same byte. It uses 8 bits from offset 0. So Z though, which is bar, it should have an error. And right, there should be, actually I should have done a Y. So Y is actually part of bar. So that's bar children Y. So then Y has an error. Y does not have a value. So assert that Y's value is none. But it should have an offset of 0 and a limit of 0. Actually, you know what would be a better test is to put another, just to put an ignore pattern here. Ignore a bit, and then give me 7 bits here. So that if I put a bit pattern of like 0, 1, or 0, 1, 0, 1, 1, 1, 1, 1, I should get back 0, 1, 0, 1, 1, 1, 1. Right? Right. And its offset will be 1. And this offset also is 1, but it has no limit. And that is because we couldn't determine a valid limit. Come on, editor. There we go. Keep Z, the other byte later. Yeah, it's whatever. What did it not like about that? Consider... Okay, fine. Whatever you want, editor. It's just that that bit is actually from here, but it's okay. Yeah, see, I thought it would fail. So on line 83, it says that bits... Oh, that's offset. Yeah. So it only parse... Oh, so I made a mistake. This always consumes bits, so this should be a 6. Because we only have 8 bits total, and that bar will actually consume a bit. So the X will actually start at offset 2. And yeah, so that's at 2 and that's at 1. This limit is actually 6. And there should be 1 less bit, which it's going to want me to move the underscore there. So the first bit is ignored, and then the 1 bit is consumed by the bounded region, and then it's the last 6 bits that we end up getting in X. 83. Yeah, so it's not actually parsing X, but I want it to. I want this to contain the error and allow bar to continue parsing, which it should. Maybe make another test for that. Well, it should continue, and then bar still has an error, but we should continue foo at that point. Yeah, let's make the little test complete here. One more bit there, and then 5 left. So that's at offset 3, and it's 5 bits long. And then we actually do have a Z, after all. And it's part of bar. Get Z. Okay, so then it doesn't have an error, and it actually has data associated with it. It has the third bit, which is a 0. And it's 1 bit long. No, not 3. 0, 1. Yeah, it's offset 2. 1 bit long. So it actually gets a 1 bit. No. That's consumed by the bounded region, so it's a 0. Yeah, so 3, 5. Yeah, okay, good. So for first things first, it should have consumed all 8 bits, and it didn't because it stopped after 3. It did 1, it did 2. Oh, so it did, right. It does parse the Z, but it doesn't, but when it gets out, it says, oh, there's an error. I don't want to continue. So that means that that was in statement, question mark. Yeah, right here. So we don't want to return an error, but we want to return a special return scope. And it would be next if, so it's a special return scope actually. Yeah, ultimately it's executing a bound statement. It does mark it as next. So maybe it's if I get an error return scope and the error flag is set. So I can look at return scope here. If error and return scope equals return scope error, will that fix it? Maybe. Inner bound 6 surpasses outer bound 2. Why does it say 6? It's like off by 1. Oh, because it's an absolute position. So I should probably translate that back into a local by subtracting the offset of the beginning, right? Or I could just keep it as an absolute bit position. So then it would be correct. Unable to parse Y. That's right. And then it got all the way back out and it failed on line 85, saying that foo had an error. Oh, so foo wasn't marked as an error. Right. We do want to mark it as an error. Too many things open. Close others. Statement. Wrong one. this one. So, there are actually two things I want to do here. If it's a return scope, it's an error, but I also want to set the self-composite error equals true universally. But if it's not an error, we don't need to return, because that's where the statement says absorbed the error. Okay, I got the bits wrong. 991. Oh yeah, because there's only 5 of them now, right? Yeah, only 5 bits. I didn't get the bits right. Okay, 1, 2, 3, and then 5 more at the end. Should be the last 5. Should all be ones. Oh, there's a 0 in there. Oh, test passed. Okay, so the diagnostic's correct. We get inner bound. So on this line, inner bound surpasses outer bound, unable to parse y. Sure. Okay. Make sure I didn't break anything else, and then we're good to go, right? Yay! Cool. So we can have errors in bounded regions, and it doesn't stop parsing in the same level or in the upper levels. But here, or where, other places where we have errors, we made sure that it doesn't continue parsing. So where was the statement like that? Part. So part's got a bunch of these, right? Actually don't see any. I want to make sure that there's at least one. Maybe it should go in here somewhere. Yeah, like let's put another X in here and make sure it only consumed 4 bits. Actually, I don't even need it to have a name. So no name for you. For bits dot borrow dot get dot offset. Yep, bar has an origin. Oh, there's problems with accumulate, weren't there? And I recorded that as to-dos, didn't I? Didn't I put that in the top to-do? Test the probably broken assignment increment decrement. Accumulate to an index of a local. Okay, so then we need to add more unit tests. So the claim is that accumulate won't work with a vector. So let's test that out. I guess we're just making a new test. Accumulate to vector component. So x equals 1 and 2. And we'll say x 0 plus equals 4. And we should get back, it's not an error. It has a vector type vec some data value unsigned integer 5. and 2. Okay, this is probably broken then, right? Failed. Panic. Assertion error, foo.error. Oh, it just seems to be an error, and there's no diagnostic. Oh, no, we're supposed to say it's not an error. Okay, never mind. Maybe it does work. Oh, it just added to the end of X. Yeah, so what it is, it looked up X, it saw that it was a vector, and then it appended to the end of it. So it's not using the index at all. Yep, that's how we broke it. So that was in reference. Probably marked it with the to do, right? Yeah, it's in here. It's this to do. Okay. So accumulate, we're not going to go into vector context. It's really we're going into the contents of a vector, really. So the problem is that we're going to descend into the value of a part. And I did that up here, right? I had like a part, a value ref. Yeah. So I want to copy this stuff, really. But we're not going to do all that ridiculousness. We're only going to do some of the ridiculousness. And here, right? Well, right here. Okay. If we have indices, so it's expect a vector value and index into it. So if the indices is not empty, then start with the value. So the value ref we can start with. That is, does it have to be a option? I don't think it does. We just say part dot value. Then iterate the indices. That we don't need care about. Wait, what is value there? Oh, that's if we get a value at the end. I won't care. I don't care about that, right? Cannot index. Yeah, okay. So then actually there is a different thing we can do here, right? So before, yeah, we did a match to see if it was a vector. Actually, why did I do it here? That's if we try to index it. But that's inside of this. If I collapse that, this right here. Wait, why are we doing that there? Oh, actually, this is what I want to do. Right, that is that now. So yeah, I just need to delete some of this. Mm, this. So value ref is an optional value, right? Okay. then I don't need to do this as ref. Oh, I do want to do the as ref because I want to get it to borrow the value. And I don't need to do the expect. Right, because it could be none, which means it's nil. And really, I just, at this point, it has to be a vector at this point. If it's not a vector, then it has to be the last one, right? Hold on. Yeah, it's this inner one we're looking at. This outer one I'm going to delete in a second. So if it's a vector, yeah, okay. If we have an index, then the thing has to be a vector. Otherwise, it's not indexable. If it is a vector, then we interpret the index. That should probably be refactored out, right? We'd have to pass in like the vector length and the expression, and then it just figures out if it's good or not and returns the actual index. Ah, I'm getting a headache. It's 5 o'clock. I'll collapse this all. Yeah, we're getting rid of this else, right? I think. Yeah. Yeah, this is all getting deleted. Save. Okay. Okay, in the end, the value equals the so yeah, I don't need this, right? Value equals some value ref clone. Oh, that's a problem. It might not be a data component, right? And in fact, it can't be a data component. It has to be a data value. Yeah, this has to be a data value. So actually, yeah, I think we're ending up returning mutable. If we get down to here, it's mutable part dot value, right? Yeah, and it's option. Okay. So that's okay with that. Problem is that I did this in the wrong order, didn't I? I have to put this after that match. And it has to be the last step. Okay. Cut and paste there. Don't need a semicolon there. Okay. So I should look at what I did in the really ugly code up here. Yeah, I had that so that if we get down into here, then that has to be some. No, it can't be some. But the real problem was it has to be the last step, right? We did this enumerate for a reason. It had to be the last step. Here somewhere there should be a check. Oh, I did it the other way. I did it where if it's if the iterations isn't empty. No, it's up here, right? Yeah, cannot path into. Okay. So that I need to have that. Actually, then I don't need the okay, the only reason I had this step was to run to print a dot. Okay, that's okay, fine. So then yeah, down here it was at the beginning, right? And then let mute value equals none. Because in the end, we're returning value. Right? Part value clone. Oh, yeah, that's true. Yeah. In fact, it's exactly the same thing as the other one. We still haven't extracted a value. Copy the value at the end of the path. Well, it's not copy. It's dereference, right? Okay, yeah, that always copied. So this is a little bit different. If we still haven't found a value, borrow. If we still haven't borrowed a value, borrow the value at the end of the path. So it's or so it's this mute clone, not clone. The type of part is wrong, value is wrong. So that's really an option mute option data value to make this one okay. All right. Got a lot of work to do to fix this up. So I'm copying this comment here. Path into our child, right? And then that comment, I don't know what happened to that. I got rid of it somehow, I think. Yeah, I don't know what happened to it, but it goes here. If we have indices, expect a vector value and index into it. All right, so path into our child, path and child match. Okay, that's wrong. Oh, I think it's actually down here, right? Then why did I have this stuff? Hold on, did I do this in the wrong order up here? I can't have done it in the wrong order. Why did I do that? Oh, I did it inside here? Hold on. That's if it has indices. Where do I do the oh, it's just that. Then why didn't I do that in the other? Why is the other one so complicated then? All this stuff. No, not that stuff. This stuff. Why is that not the same as that? So that's what we did in the other function. Why is that more complicated? Occupied. Oh, because of these extra things? Right, if it's the first step, it must have no origin in the bitstream. And if it's vacant, we have to insert one. Yes. Okay, so it's just a little bit more complicated, but it's still something we do first. So it deserves another comment, and that's not the code we want. So well, actually, this is all pathing into the child. These comments explain what we're doing. We're creating a local if this is the first step. It can't have an origin. Yeah. Okay, so delete that. Okay, so that That sets up the part. We can't do that if we have a value. So yeah, if we have an indices, then it better be the last step. Otherwise, we can't path into it. So we're going to extract a value from this, right? So it's going to be that, right? So then loop for all of that, and we're not getting a clone. We're getting we're actually just copying that, right? This is mutable. Okay, and how did I get errors up here? Oh, because this should be an option data value, not a data component. Okay. Okay. Mutable. As mute. Values as mute. Almost. No, not as mute. I think I'd have to do a values.getMute. Yeah, don't just do that. Mute option, so as ref, as mute. Option mute option. That's a problem, right? Expected to mute. Oh, there's no sum. Yeah, okay. Okay. The negative case is easier to handle. So if the value is not a vector, it's not indexable, and it's returning an error. Yeah. If it is indexable, getting the index from what? The values in the vector, right? And we're just using it to index. I mean, that should work. Just now I have to track down the errors. Is there a reason for using nil versus returning a none? Not really. That's another thing I might change in my design. So right now, value has no nil variant because I thought maybe foolishly, I thought that it was better to use option value and none is the same as nil. Problem is it's infected a lot of things here. So like that's why we're returning option data value because it might be a none, which is a nil, right? But it makes it a lot more complicated. It would be simpler if nil was a kind of data value, and then there's always a data value there. It just maybe is nil if you haven't put a value there. Versus like this, and this is sort of ambiguous. It's like, does it mean that there's a value there, or not, or could it be nil? Yeah, is nil a value? So the question I think comes down to: do I ever have a case where I need to distinguish between the value being nil and not having a value at all? And I'm probably that's going to be one of the next things to deal with. But right now, I'm fixing this one specific problem that we cannot dereference into a local vector. So once I get that done, maybe we'll make that the next thing to consider. As long as my headache doesn't kill me. We have 10 errors I need to get to though. Right, so then this is actually not giving us a component anymore. It's giving us a value. So I was always just getting to the value anyway, right? So don't I just get rid of this? So it's just local or as mute. And then local equals. Yeah, there we go. So same thing here, like this is local equal. All right. Decrement. So again, this just does match on local, right? Cannot accumulate to a nil. Sum, and yeah, this all works. Cool. Yeah, so then I never really needed the component, right? It's always just getting me the value. So it's just reassign the value there. Nice. Same thing, like when I was writing this, I should have just realized I only looked at the value of it, not the component. 3 errors left. Can't borrow. Okay, we have a borrow issue. Borrow issue 215. We borrowed from self, and then what did we use self for? We tried to borrow from part, and it said, no, that's not it. It's here. Oh, we can't evaluate an expression because we're borrowing into self. Wait, this shouldn't have borrowed into self. It does though. How did I get away with it in the other place? In dereference, I also borrowed from self. How did this work? Oh, because it's immutable. Right. So in this case, we actually want a mutable reference. So we can't use self for anything else, including evaluating expressions. Well, I could put it inside a ref cell, right? Or can I? I'd have to take the composite out, I think. But we want that mutable reference to flow through, right? I probably need to say it comes from that. Yeah, let me think. Let me see. That's a borrow problem, not a lifetime problem, right? What's the lifetime problem? Well, that's because this is as mute. It should be as mute. How do we move it? Moved on 258. Mutable option. So this should turn into an option mutable reference. Right, it's a mutable value at. So where am I actually moving it out? I don't get that. Moved into, it says it's moved here. Borrowing this binding in the pattern to, borrow this binding in the pattern to avoid moving the value. So it's ref? Or is it ref on the other side? Okay, I'll have to get back to that one. I want to get the lifetime issue. I think it has to do with this, right? No. So what's the lifetime? There is no lifetime issue. I resolved it. No, there's still a lifetime issue. Original diagnostic on 330. Oh. Potential spam alert. All declined. More than once at a time. I think I can guarantee that. I just have to mark it so. It doesn't like self as a keyword. A. That didn't fix it. So it's not that the lifetime is confused with the reference lifetime. It's that it all comes from having immutable references and then moving around through the composite. So like if I just hard coded that to 0 for a moment. I can't do that. Match 0. Or match none. Actually, let's just hard code it to match some. Yeah, we'll just hard code something in here. 0. Hold on. I think it's time to get a full screen diagnostic. So cargo Clippy. So it says to put it there. So let's try that. Okay, I did what it said. Okay, I can't borrow it twice, I think is what it's saying. So I have to do this some other way. What am I using that for? I don't think I'm using it for anything. So I don't actually need that binding. Yeah, that, don't know why that was there. Left over from something else, I guess. So I don't actually see where the other error is. Oh, there it is. Oh, I was using it there. We'll just do that. I never needed the index. Oh, because of this. Yeah, well, that's another problem to solve. What's so this thinks that I am borrowing it twice on 255. Value ref, yes. But I should take, okay, is value ref, it's a reference. Okay, but then I take it out there, or I bundle it. It kind of, I think it doesn't see that if it's not actually holding a reference that we can borrow again. So what if we just do it this way? If value dot is none, okay, mute part value, else, okay, value unwrap. It still thinks we're using value ref down here. Okay, but can I just drop value? Okay, how about I do it this other way? If it's sum, then return this. Still doesn't like it. How can I tell it I don't want that borrow anymore? I don't want value ref. Can we just drop it? Drop value ref. Oh, shoot. Is it because value? Okay. Where is that borrow? How is that borrow infecting things? See, that reference is only used to like update not path it's only used, it goes into value, right? But if I drop value, I shouldn't need to It doesn't know that I'm not using value anymore, but it says, oh, you can't borrow from part because that's a multi-borrow because you already borrowed from part right here. It's like, well, sure, I borrowed from that, but I should be done with it by now. In fact, if I try to drop it, it won't. It should see that I moved it out there, unless there's another path I'm not seeing. Maybe it's because of these returns. I don't know. Okay, so I need to write this a different way. It's obviously like confused. Oh, there's also this problem that I can't do. I can't evaluate expressions while I'm holding a mutable reference to self. Else, you mean to try else? Yeah, it doesn't help. There's something else. It's just like the analysis is not good enough to see that and this doesn't help it. It doesn't see that we're not using value ref. Sure, it goes through a loop, right? But value ref goes into value, and then this is a big loop, right? So we eventually fall out of the loop, and then if it's none, not only should we not have a borrow anymore, but yeah, I should be able to borrow from part again, but it won't let me. It might be. Is it because it's like there's a loop and then there's a return path out? Maybe. I don't know, something going on. But yeah, the biggest problem is that we have it's because I want mutable reference returned. And we have to walk an internal data structure. So we're taking a self reference and like we're borrowing from self. I think that's the problem. We're borrowing for too long. And there are too many branches in the code, and just so it doesn't see that I might want to borrow from there. So I think maybe I have to like break this up into smaller functions. Like the root of the problem is in this thing, right? In that. So what if I like made that another function? And what if I pulled it out of the for loop? Because really, this should only be if it's the last step. So what I could do is if I could just take the last part of the reference chain off and use that separately. Yeah, I'll be right back. Share stream for a little bit. I'm actually more concerned about this problem of I need to evaluate the index expressions. So actually, I should probably do that separately. I should just like evaluate all the index expressions, pre-evaluate them. Then when I descend into the data structure, I won't have this borrow problem. So let's try to resolve these separately. So I'll hack that for now. So we're not actually using the index anymore. But just to solve this, my theory is that if I could move this outside of this loop, then it should be able to see that this value ref, its borrow goes into value. And so if value is nothing, I should be able to borrow from something else. But I could be wrong. So I want to move this out of this loop here. Well, what's the best way to do that? We could take this indices part and like give it to the next loop so that we move this to the top and well, we take it out completely. So that would be an enumerate and then a fold, wouldn't it? Or reduce. I think so. Yeah, I think what we can do is we can ignore this inside the loop, and then when we get out of the loop, well, not ignore it. If we see it in the loop at the beginning, I guess, or we can just ignore it. We can ignore it while we're seeing that dot path. I know. What we'll do is I'll have a let mute indices equal none. Okay. Then if we have them, right. So this moves outside the loop. Big move, okay? But I also want to grab that after we path into the child. We'll say if there are indices, if indices is sum, we got a problem, right? Then it's an error. Path. What do I say here? I say something. Hold on. Cat wants in. Kitty cat wants in. Is kitty cat hungry? Meow. Meow. The cat's food is here in the office, so I have to let her in to eat. Okay, this means we've already run into some indices. So that would mean like we did like x sub 0 and then a dot and then something else. And it's like, actually, then it should be the other way around. If it is sum, it's an error. There we go. Actually, then it moves all the way to the top. Yeah. Oh, then the value can move down too, right? Yeah, because it's just the value of the last part in the reference chain. Yeah, okay, so this can actually move out. Delete that. It's really if indices is sum, then cannot path in, yeah, exactly, can't path into that path. Exactly. So it's the indices we want, because we're moving that out and we're doing it later. So then we path into it. So there's a dot something. And then if it's not empty, now we have indices that we're pathing into a vector. So then we do indices equals sum. I think we'll just clone this. Just a vector of expressions. Oh, actually, we could do the evaluation of all of the indices here, right? Because, well, actually, we can't because we're that's the other problem, right? So I might have to pre-compute the indices outside of this. But okay, for now, let's just clone them. Clone them. Will it let me do that? Is it not clonable? It's not clonable. Okay. Can I borrow from it? I should be able to because it comes from reference. So can I borrow the indices? Yes, I can borrow from the indices. All right. So then we say if indices is empty, if not indices is empty, is if indices, actually it's a nested loop, right? If let, well, actually, if even if it's none, we just end up getting its own the value, right? So it's really it's if we actually don't need this, or this moves into here really. If let some indices equal indices, then loop them. So the match collapses, that goes there, that goes there. And we get rid of that. Okay. So for index in indices. So that's a borrowed expression, right? Then we'll have to figure out how to evaluate them. But let's say we evaluate them all. Right, we say let value equals, okay, then I don't need to do this thing, right? Value is always something. Yeah, wait. I don't need to do this because we already did it. So we're just returning some value reference. We're returning okay. So it's okay value ref. Okay value ref. Done. Okay, cool. We fixed it. So if we have indices, we have to expect a vector value and go, yeah, that makes sense. Okay, what's the hotkey used to preview inferred types quickly? For me, I had to remap it. So for me, I do Control Alt, but I remapped it. Setting keyboard shortcuts, right? So it's when I hold down these two. Oh, it's not mapped through VS Code actually. It's mapped through the settings of yeah, I can show you in the settings. It's mapped for a Rust analyzer somewhere. It's here somewhere. Maybe? Inline, inlay hints. Okay, now I'm confused. Is it in shortcuts it's called inlay hints or something? I don't know. Controls the alt default for Rust down there, but there's a setting to change the default. Yeah, I'm trying to find that, but I don't know where it is now. I don't know. Settings. Maybe it's if I open it in the UI. Inlay. I'm not sure where it would be. Here somewhere? Does it like have the key to the inlay hint key? I don't know. I guess I never really changed it. It's just Control Alt for me. Yeah, the toggleable one is this off unless pressed. So that's actually a recent thing. It used to be that you had to hit a key and it would toggle it on. Actually, I kind of prefer the way it used to be. It used to be that you'd hit some key and it would just stay on, and then you hit a key again and it would turn off. Now I have to hold something down, which is sort of annoying. There's like no way to like toggle inlay hints anymore. They got rid of that command. Toggle inlay hints, right? There's no toggle inlay hints anymore. If there is a toggle, I'd love to know what it is, because there's no command for it. Just toggle word wrap, toggle line comment, toggle float, block comment, but there's no toggle inlay hints anymore. Again, the inlay hint setting. Why did they move it there? See, so I think I know what you're saying. You're saying that if I go here and I turn this to... Okay, there it says, see how it says Control Alt? So it can be on or it can be off. There's no way to change this with a key command, with a command. That's the problem. I want a command, like I want to hit a shortcut to turn it on, and then when I hit a shortcut again and turn it off, I don't want to have to go into my settings and just turn it on or turn it off. It used to be toggleable and they got rid of it for some reason. I don't know why. Yeah. And how are you doing though, Joe Mega? Yeah, Control Alt. I've gotten used to it. Yeah, I try not to complain too much. Okay, so I need to solve the problem of like this. I can't, it won't let me borrow from self, right? Because we're borrowing by descending into the component mutably, we can't use self for any other purpose. So really what I do is I want to evaluate all the expressions up front. So if I locate these indices, I guess I would have to, it's always going to be the last one, right? Because if it wasn't the last one, we'll hit this error. So what I could do is I could just pre-compute them before we even borrow from the part. Pre-compute the any indices in the reference, since once we start walking the component's value structure, we won't be able to borrow from self again. So that means we'll need to have like the indices all pre-computed. So that's a vector of uint of u sizes. Okay, and then so we'll pretend we've made them up there, and then we'll use them here, right? So I'm going to copy this twice. because we need the code to compute it up here. But then down here, we'll just walk it. So if, yeah. Okay. So we're deleting it from here. Well, hold on. I guess we're detecting at the start if there are indices in the middle of the path, right? So I don't need, let's copy this and I'll put it here in a comment because we're gonna want to have this code. That code goes in when we walk it the first time, right? Path into our, so we're always pathing into the child. And yeah, this is how we get them out here. So I need that chunk of code later. Okay, so we're pre-computing all the indices, and then once we're done, we have them. So that's gone. And then we'll have them here. They are they're not expressions anymore. So what's wrong? It should be vector view sizes. Why is this? Hold on. I gotta comment this out, I guess. Because I want to only work on one section of code at once. So just assume that they are vector view sizes. So down here, I should have a u size. So I don't have any if lets. It's just for loop, which makes sense. Because if we had no indices, then we never descend into that. So say that. So each index is a u size. So get the value ref as a mute. If it's a values, then I don't need to match that anymore. It's just index. Actually, we will all have already done all this stuff, right? So I will have converted it. Actually, hold on. We won't know the length. We won't know the length. So let's make it an I size to allow negative numbers. Okay. So there's an I size now. Reworking some math stuff. I'm reworking some code stuff. Also started a second side project, a CPU emulator, maybe extending it later. Cool. Which CPU? Are you starting with something simple like 6502? If you emulate the 6502, and then you also emulate a few hardware devices, you can actually make your own Nintendo. Starting with the RISC V. I don't even know what that is. 6502 is one of the simplest CPUs though, right? If I were to make an emulator, that's the first one I would make, because I think it would be cool to make something that could play old console games. I would have to emulate the display and the input system and the sound, which would be hard. But the CPU wouldn't be too bad, right? Also, I guess the ROMs. I'd have to have the ROMs available. 4004 is probably the simplest. Simpler than the 6502? Okay, we got to compare then. Which is simpler? 4004 instruction set. Give it to me, Wikipedia. A 4-bit CPU. Okay, maybe because 6502 is 8-bit. Okay, there are 16 index. This is way more way more registers in the 6502. Can I like just see the instructions? Okay, here, how about here? Okay, there's the instruction set. There's that many instructions. Okay, how about 6502 instruction set? Help if I spelled it correctly. Okay, this isn't in as nice of a format, but what if I go to here? No, that's the Wikipedia page. How about here? I want it in one table. Okay, the format isn't the same. Like, I think maybe the 4004 wins because I think that's fewer than this. I think there are a bit more. The register set is like really tiny on the 6502. It's got like an A, an X, a Y, and an index and a program counter and a stack counter, and that's it. Talk about the registers. Yeah. So it's like you have A, you have X, you have Y, and that's about all you can do. There's a stack and a program counter and an index, I think, or maybe the X and the Y are index registers, but yeah, that's what I grew up with. Plus, it's also the original Nintendo Entertainment System CPU. So, or is it? I think it is, right? I might be wrong about this. Am I just blowing smoke? What's an NES CPU? Is it 6502? Yes. Two CPUs. Oh, they're just two different consoles. NTSC and PAL. Yeah. Because it was specifically designed for electric calculators? So for some reason my cat is rummaging around in my shred bin. Should I be concerned? Okay, I don't need a sum, do I? This should have been caught earlier. So all these sums go away, and so this should be like index if index is greater than 0. And this is index if, well, this is the same, right? So I can delete this. And this is just index. Well, to be nice and balanced, it would be less than 0. So this is greater than or equal to 0. Why is it not covered? I'm covering everything. Okay, fine. We'll just do index. Got to be less than 0 if it's not greater than or equal to 0. So there's no, yeah, this. Oh, it's I64? Okay, we'll do I size. Okay, that actually worked. So that's promising. So if we have pre-computed indices, then we'll have no trouble walking the structure. Problem is pre-computing them. So that's what we're doing next. Here we go. So, not this exactly, right? So we're still following this. Actually, and I'm still gonna have a path too. Yes. And we need to, well, I need to compute a path too. But I can skip that match part, right? Hold on. Yes. Okay, so this outer loop is still present. So I do want to do a none, right? Yeah, because we still want to do the same kind of thing. So this is going to be an option. Let be path, string new. I still doing this step counter because we're putting dots. And here's where I need this block of code. That goes up here. if we've extracted indices, if we've already extracted indices, it's an error to not be at the end of the path. Cannot path into that. All right. Is it getting dark? 6 hours? I kind of want that line to go there. And then I want that line. Okay, down here. It's a mess, isn't it? If we have indices, evaluate them. Okay, so can't have any indices to every loop. So it has to be at the end. So if we have indices, evaluate them. So if it's not empty, then, okay, we don't need that. We're looking at all the indices. So delete, 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 delete. Okay. I just want this inner thing here. Blah, 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 all this. Yeah. Whether or not it's indexable is another story, right? Hold on. We did use it down here correctly, right? Yeah, it is not indexable. So that part is at the bottom. So I can delete that. Okay, and then we don't have that. Risk V is an open ISA, so no licensing. You can just make stuff for it. It was originally started as UC Berkeley. Started at UC Berkeley. That's cool. So no IP. Hopefully the formatter will come to my rescue soon. So if there are indices in the ref part for index in indices, so we're really just building indices here at this point, right? Let index be something, and yeah, I need to like append it. So then really what I'm doing is I'm taking the indices. See, if it wasn't for these errors, what I would do is I would just map the indices. I guess we could still do that. We can have a result, right? So it would be ref part indices dot map index to this, and then we're going to do a match. And here's where we do an early out, which means the map has to have an early out. But we'll get either some unsigned integer, some signed integer that's positive, or we get a signed integer that's negative, or we get something that's not an integer at all. And then we want that to yield the index, right? Okay, cool. Then when we get that, we want to collect all of these into a result, right? And that's what we're putting into path. No, indices. Sum of this. Yes. Okay, so I got many errors to deal with. First of all, what's map? Probably because this is a vector, so I have to do like iter, and then I can map it. Okay, and then I probably don't have matching braces. Probably because there's a semicolon there. Okay, that's better. The match expected found use size. Where? Okay, for one, we want it to be eye size. We don't do a length comparison. We just keep it. So it's just index as eye size. Okay, and if it's greater than or equal to 0, actually, it doesn't matter here. It's just, there's no if. We're just putting it into the path, and then we're doing index as eye size, right? So we don't need this other check. If it's not an integer type, if it's not an integer type, then it can't be used as an index to path. Wow, okay. This got cut up bad. Like that got chopped. Okay. Probably because I put this inside of a format. What happened here? I don't know what happened here. Wow, what happened here? Oh, I see what happened. This is the if it's something, then turn it into a string, else turn it in, else it's a nil. So okay, it's looking better. The whole thing is a problem because of well, shouldn't this be a result of eye size and an error? And then we collect it and do that. Comma. Okay, there's still a problem inside here. Return type prefer to be result string. Yes, that's correct. Expected result eye size string found eye size. Okay, where? Where did it find that? Mismatch type here? Oh, we had to turn it into an okay, I guess? Yes. Well, it should be let's take this index and do let index equal that with a question mark. Type of index is an optional value. Match it. I want an eye size out. Oh, but there's an error. Shoot. Okay. Okay. I know what the problem is. This needs to do error. Early exit. Okay, and getting close. Get rid of the semicolon. Okay, what about this? Is that by itself? Oh, no, hold on. That is an option value, and if we can get out, the collect is wrong. So why is this collect wrong? Cannot be built over. Okay, it thinks that it's an iterator of eye sizes. I think it's because it's not map, right? Well, okay, I think I have to, yeah, the only way to do this, I think, is to do this. And then not return here, and then collect it. Maybe that's what I should have done all along. Okay, that seemed to work. So yeah, we don't need that anymore. So why do I have errors down here? Because the errors are use sizes. Why are they use sizes? Oh. Hold on. Indices is a vector of I sizes. What's the error then? Found I size find in. Why is it for index and indices? Now, why is index? Oh, I need to unwrap that. Yeah. Because we might not have indices, actually. We might not have them. If let some indices equal indices, then loop them. Okay, and now we're back up to here with an error. Because it's not mutable. Well, make it mutable. And now we pass it. Okay. Super ugly. Okay, well, the good news is it compiles. So we're back to accumulate to see if this actually works. Oh, good God. It worked. So again, it's been a long time, but the last time we were here in this unit test, it was that we could start with a vector 1 and 2, and we could add 4 to one of them. So to prove that we're actually getting an L value and we're indexing, right? So that's big. Base instructions, that's extremely basic, not even multiply divide. Well, the 6502 doesn't have multiply or divide. Actually, it has, I think it might have multiply, but not divide. With 32-bit one having 40 instructions. Think like about RISC V, like ARM has 32 registers. x86, well, 6502 only has like 5. So that's a general property of RISC versus CISC, right? RISC is reduced instruction set compute or whatever. You have fewer types of instructions, but you have more registers. And then like the more monolithic has way more instructions but fewer registers. Because the idea was you move all of your instructions do more. You have more microcode in them. Whereas a RISC, you have less microcode. You have more instructions, but you have more registers to play with. Hold on, I gotta close my blinds. Okay, so dare I run my own unit tests again? It's been a while. Yay! Woohoo! All right, now this is a monster. We had to pre-compute indices. This makes me think that this should be a separate step completely, right? This should be a separate step completely. For one, and then what we can do, actually, I can, if it's a separate function, we can do an early return if it's empty. And then we won't have to do an equal sum. Yeah, so let's do that. So that's all of this stuff, right? Refactor into function. Evaluate reference indices. So this is just evaluate reference indices, and it has an early return. Cool. Registers has nothing to do with RISC or CISC. It's more an arbitrary decision. I thought it was that RISC tended to have more registers than CISC. thing I always thought I was confusing with RISC. I thought it was trying to reduce the amount of instructions. No, it's the opposite. It was reduce the complexity of instructions. You have more of them, but they're less complex. Make each instruction do the least amount of work. Yeah. Yep, you got it. I think it's called reduced instruction set because the instructions are reduced and do less work. Like the instructions aren't. So you end up having fewer instructions because they do simpler things, right? Yeah, x86-64 is something like 2,000 instructions because you use fewer of them because you select a subset of that 2,000 that does more. Each of those instructions like does more because they're like, it's like you have 2,000 functions that that overlap in a lot of different ways, but really you only have like maybe 100 unique things that you can do. It's just that they vary by like what paths through the register file it takes, right? So it's just moving the complexity around between the instructions and their microcode and the developer's program. So, but hasn't RISC won at this point? It's like proven, like all the architectures that are surviving are RISC based. How much can we pack the machine code because memory is expensive? Yeah, make the program smaller, but memory isn't expensive, it turns out, right? Unless it's maybe a highly specialized embedded platform. I don't think x86-64 is still king. How many Android phones are there out there? They don't run x86 at all. They're all ARM, aren't they? Let's see. How many cell phones? How about cell phone CPU types? So it doesn't say the kind, but I don't like these are all ARM based, right? Well, how about CPU ARM versus x86? This sounds like a chat GPT question. Why do I have another dashboard window up? Okay, chat GPT. Chat GPT 4 has been updated. But I'm not paying for that. Okay, so what percentage of cell phones use x86 based CPUs? Vast majority of cell phones use ARM-based CPUs. It didn't give me a percentage, just said vast majority. Okay, how about we say the same thing? How about personal computers? Majority of personal computers use x86-based CPUs. However, it's worth noting that ARM-based CPUs have been gaining traction in the personal computing space, especially in certain niche markets like ultra-portable laptops and devices that prioritize power for efficiency. Okay, so depends on your perspective. Phones versus PCs, right? So that's hard to call to make because one could argue that like there are a lot more cell phones than PCs now, right? Actually, that's another great chat GPT question. Are there more cell phones than PCs? Okay, as of it only knows up to 2022. There were more cell phones in the world than personal computers. The trend has been. It doesn't say like what's the ratio of cell phones to PCs. It just says there are more, significantly higher, several times more cell phones than PCs. More than 10 to 1. Ratio is significantly higher than 100 to 1. I want it to give me a ballpark figure. It's possible that the ratio of phones to PCs could be in the vicinity of 100 to 1 or higher given the widespread adoption. Now it's starting to like caution me that it doesn't have the most up-to-date information. Consult. Okay. As of January 2022, what would you guess the ratio to be? Could be well above 100 to 1, possibly even higher. It really is hesitating to give me an answer. Got to include servers? Well, okay, I already closed ChatGPT, but that would be another question. What's the ratio of servers to personal computers, right? And does it really matter to count to compare counts? Like you could also compare it in price or in cost to manufacture or compute hours actually used. Yeah, I think there are too many variables to make a fair comparison. But certainly, we no longer see PowerPC anymore, right? So they lost. What else? PS2 operating system, OS2. IBM's OS2 lost to Windows, Linux, etc. Right? Okay, to do. We still might do that. So evaluate. Let's clean this up. Yeah. So if this is empty, then continue. And I can remove a bracket. Okay. Okay, and then I think we can refactor this one too, right? Turning an expression into an index based off of whether it can be an index or not. Refactor function. And why are we still using self? Because we're using evaluate expression, right? Evaluate expression for index. How about evaluate index expression? Why do we need a path? Oh, because we're descending in there. Well, so it's evaluate index expression, add to path. Yeah, well, it's okay. Actually, don't need to, yeah, that's why we're returning it back out, right? No, we're not returning it back out. This actually doesn't get the correct path, does it? Yeah, we have to actually borrow mutably the path. Oh, actually, we're reassigning. No, we're plus equals works by like that allows me to do. I can do that, right? As long as I dereference, right? Yeah. Okay. Then we're good again. Yeah, it has that. There's the weird side effect of building the path while we're going. Okay, then this isn't so bad, right? And the only point at which moving away from x86 when it comes to performance is when there is an ARM or RISC-V besides a Boolean performance over the same generation x86 CPU. Yeah, I don't know. As you can tell, I'm on a Mac Studio, and that's an M1, so I'm coming to you live from an ARM processor. So I might be biased as an owner of that. Can we do this in a better way? Cannot be used. Okay, we can at least take this out. And I just realized I never escaped the line to begin with. Well, this will be fixed if I explore that next adventure, which is maybe turn optional data value into data value. I think that's coming up next. I think we're gonna see if it's possible to get rid of option data value and just fold nil into it. I think it's probably okay. Okay, so the rest of dereference local mute needs to be cleaned up. So indices is great. So then we're navigating. I guess, I could just refactor this into 3 functions, right? Yeah, why not? So what are we getting out of this? We're getting a part, really. And we're getting a borrow from self for that part. And we're not using self for anything else after that, which is good. If we get to the point where we see Intel and AMD move away from x86 and focusing on ARM or RISC, then we could say that x86 has lost. So the theory that you have, I guess, is that x86 is too well entrenched in the world to ever go away. It might move out of the PC space, though. If new PCs start to come out with ARM, and then more and more things have, like if Windows for ARM is a thing, right? But if like that had parity with Windows for x86, and you can have Windows for ARM on an ARM-based PC, and if new PCs were built more for ARM than x86, over time, x86 could be marginalized away to where like Intel decides to move away from it. Or maybe Intel gets bought by ARM and then they move everyone else over to the ARM. Right? Something like that could happen. And then you still have x86, but we sort of relegated to like where it's still used, I guess. Is x86 still entrenched on the server side? Another question for ChatGPT. ChatGPT, what is the most popular CPU architecture in servers? x86. It's the most popular. Intel's Xeon and AMD's EPYC processors. I didn't know they called it EPYC. EPYC. Okay. Well, then, if they're entrenched in the server, that makes it harder. Because then they'd have to lose popularity both on PCs and in servers. So that's probably not going to happen anytime soon. So we're probably doomed to have ARM and x86 around forever, right? The exception use cases where power efficiency is preferred. Right, like cell phones. So we'll get to the point where all cell phones are ARM probably, and x86 is still very popular outside of that space. This should be easily refactorable, right? Because what we get out of this is the part. We don't need the path after this, right? No, we still need path. So really I should kind of do this. Let's see what happens if I refactor this. Refactor, extract into function. It got really confused. Okay, undo that. What if I include the lets? It's still quite complex in its return value. Error, look at that, error. It's really confused. Okay, I think I got to do it manually. This is going to be like walk composite structure, right? Wait, don't I need to like have a check for indices? Oh no, I already do that here, right? This does that check, I think. Yeah. Okay, so we don't need to worry about indices. We've separated that concern out. Okay. So I'm just gonna make a function, make sure we can, so this is gonna be walk reference path mutable self. I don't know what we're returning yet. Paste and see what we're returning. Okay, we need a path. So why don't we just return a path? So let's have a struct. I can't define it here. I guess a tuple for now. So we're gonna have a string path. We're gonna have a mutable reference to a data component. Anything else? We also need self. Okay, so then it's the reference. And this all might blow up, so it has to be a result. Okay. So at the end, we're returning okay path apart path. And require existing is another argument. See, that's how it should have refactored it. I don't know why I couldn't do that on its own. Probably because I was taking lines out that it still needed. So let mute. Actually, we probably don't need to mutate the part anymore. Let path. No, we need to mutate the part, but not the path. Oh, actually, we need to mutate both of them. Equals self dot walk reference path reference require existing question mark semicolon. Oh, I didn't need to mutate path part. Okay. And that type is right because it's a mutable reference, so we're not walking anymore after we walk. Path is mutable because we continue to update it as we're walking down the index path. Hey there, JP Post 2000. How are you doing? I'm just cleaning up some really gnarly code here. So now the first, so you know, if I follow this trend, then the third thing should also just be refactored out, right? This is like walk index path is what it is. Yeah, so why don't I just refactor this as walk index path? All this loop, right? That, one more line down, copy it, and we do walk index path. I don't know what other things we're going to need, but definitely there's a result. Hopefully we're getting a mutable data value out of it. And right now it's an option, which is unfortunate, but maybe we'll fix that in a minute. And string. And I hit the paste key. Okay. I'm pretty good. What was written yesterday? I'll show you. You were here yesterday, right? So in vector tests. So there's now the concept of Where's a good example? Here. I guess this is it. There's a concept of parsing something inside of a loop. So review again, right? The way you interpret this statement is we are parsing 8 bits as an unsigned integer, and we're going to name it x. So normally, when you do this the second time through the loop, you'd have a collision because we already have an x with an inside foo. So foo.x is now ambiguous. Which byte are we talking about, right? So I introduced the concept of a vector context. So every time you go into a loop, we push an index onto a stack somewhere. And then whenever we parse a part, the part immediately becomes a vector, and we actually store into the slot number that corresponds to what's on the loop stack. And if it's a nested loop, we'll have like a list of indices on the stack, and we'll actually use them both. Like we used all of them. So like if it's a single loop, we'll have a single dimensional vector. If it's a nested loop, then we have a 2-dimensional vector. And there's no collision as long as we don't have an x twice in the same loop context. If I did that, now there's a collision because we have 2 x's in the same loop, right? So that's a simple test. Can we parse 2 bytes and name both bytes x so that it ends up in a vector called x? So when we get x, we should get the vector of the values out, and each slot has 8 bits from it, right? And we can go in and we can actually look at the individual elements, the iterations of x, and we can see that they're the separate bytes, and it remembers where they were. So the more complicated case is we have like nested loops, and then you can have holes because you don't parse sometimes, and it makes sure that the holes are where they should be. The disparate parts of the bit stream are collected together into the same outputs, and that all works. So that took like hours and hours and hours yesterday. Haven't done any meaningful work since April. Also, never that good at parsing. The fortunate thing is, a lot of times, standard libraries for languages do the parsing for you. So, for example, if I go to value.rs, I can show you how unsigned integers are parsed. Where's that done exactly? Oh, didn't we do that? Don't we do that in the okay, one is when we do a cast from string to unsigned integer, that does it there, right? Yeah, so like Rust has built-in parse function for a lot of different types. So anything that starts out as a string can be parsed to most numbers just by calling the parse function. And you get different kinds of errors. Like if you're trying to parse a string as an integer, you get a parse int error. So, but otherwise, it like kind of handles it for you. So the elementary things are pretty easy to handle if you know the standard library function to do it. It's just the higher order things that are hard. So like an example of that might be, like it's easy to parse a base 10 number, right? You just call parse. And if you don't care about the error, you just do okay, and then you either get something or you don't, right? But if you're doing like base 16, then you have to do from string radix and then 16. And same thing with base 8, right? Or base 2. And then if you do things like I do, where your regular expression has this B in there to mark that it's a binary or a hex or something like that, then you have to like extract out, cut that character out, because the from str radix doesn't want to see that. So in my code, I had to like split. I had to have a function to split it, and then to get the sign and the digits separate. So the sign is on the left and the digits are on the right. And then the split is like we strip the prefix, and then we take the slice to the right, and we have to handle, it might be a plus prefix or a negative prefix. So it's like, that's where it gets a little goofy. But yeah. The hard part I'm dealing with today is in my reference testing.
So I wasn't handling this case where you can have a L value reference that descends into a vector. So it was, what it was doing is ignoring the index here, and it was just adding 4 to the vector. So the vector was now 1, 2, 4, where it really should, when it's in an index, it should descend into the vector and get a reference, an L value reference to the 1, so that when we add 4, we get 5 and 2. And that took a bunch of work. My goodness. Because we need a mutable reference, and when we're getting a mutable reference, we can't use ourself for anything else. And yeah, it's a pain. I had to pre-compute the indices, then walk the path of the component, right? So pre-compute the indices, because after this, we're not going to be able to borrow from self anymore. Then walk the reference path, and then this is the last part of refactoring now, to walk the index path. So actually need a comment here. Find the innermost component. Yeah, so if we're having an L value reference, it has to be of the form that first it's a path through components, and then it's a path through a vector value. We don't support like going into a vector component and then into its children, because that would be changing a part, and we don't allow that. We only allow that for local values anyway. So it's not even going to look. You can always do a function with self-fun. But yeah, I think this, we also like don't allow it to be, yeah, if there's a bit stream associated with something, we stop you. We say, you can't get an L value reference because it has an origin. Is that a loop with a string and it parses each bit? Where was that again? That was accumulate or vector? Vector? You mean the simple example here? This is a loop with just loops twice, and then this is parsing 8 bits as a number. Did you mean this one right here? It's just this is an extended version of that, where we have an inner loop and an outer loop, and there's a parsing happening there, there, and there. So wherever you see the UI, it's actually parsing out unsigned integer from bits from the input. Everything else is either a conditional or a loop here. And if you were talking about the accumulate, we're not doing any parsing at all, so I don't have any bytes. It's just constructing a local vector and then updating one element of it. If we're talking about the code, what I'm doing I am doing stuff with the string. This path here is what we're building it so that when we print out error messages, we can say like, for a path, something was out of range. It's really just reconstructing in string form the partial reference. So like you might say x sub 0 dot y sub 1 sub 2, and I'm going to print that out as a string if it gets to that part of your reference and it's bad. So as we're walking the reference path, we're accumulating the parts of it, like x dot y dot z. So there's where we're putting the dot on. We only do it if we're not on the first step. We add the identifier from the part of the path. So this reference type is just a new type for a vector of reference parts. And reference part has a string, which is the identifier parts, like x, and then the indices, which is a vector of expression. So that'd be like in square brackets 0 or 1 or something else. So I've been testing with really simple references. So there's the identifier, and it's got one index. If we had 2 indices, it would be something like that, right? Each of these is an expression, so I could do something like that. So then it would evaluate that one first and get 2, and then it would assume that x0 is itself a vector, and it would go to the second or the third element of that. Yeah, they're allowed to nest because expressions can be references. Not L value references though. There are two kinds of references. That's an L value reference because it's in the context of a accumulate, right? Here's a non L value reference. That's an R value reference. So that doesn't have to be. We don't need mutable access to it. We're just going to copy out of it. And there we're allowed to like reach into parts. So you could do that if X was an array of parts and it has subpart Y, then we could totally do that. But you would not be allowed to do that because we don't allow you to descend into parts at all in the first place. Okay. I need to fix this. I broke this, right? So, oh, it needs the indices. Indices is vector of I sizes. Okay, and then in the end, we need the data value. And we have a path. That we can own. We need a value reference. Actually, I can't use self anymore, right? So that's a class method. Value reference is a mutable reference to a data value. So walk index path is a self. That's oh, we're not calling it yet. Yeah, anyway. What am I returning at the end? I'm getting lost. What do you say about that reference again? I totally don't know what you mean. Sorry. I'm like doing like I'm on to step like 4 or 5, and I think you might have asked about step 2, so I'm not sure which step that was for. Yeah, did I pull the wrong stuff out of there? Foreign index and indices. Okay, so that is a mutable reference to an optional data value. And what is the idea is we're updating it? Yes. Okay, so the idea is we're going to return it back out. So it comes in and then it comes back out there. So if we get to the end, then we're doing okay value ref. Cool. Almost done. That's the only problem I have, right? So it has to be marked as mutable. Cool. Okay, so that actually compiles. So let's try to use it up here. So that's this, right? Value ref equals self walk index path value ref indices path. Yes. So delete all this stuff, right? Question mark at the end. Okay, cool. So it doesn't need to be mutable. Even better. And I can just do this, right? I can take that and put it. Oh, wait, no. That's conditionally we do that. Okay. So that's as reduced as I can make that. Okay, so can I cut this down in size somehow? So I can do something like where it's an error if it's something that's not a vector, but then like I'm gonna end up wanting a match anyway, right? Let index equal. Okay, well, one thing is this can move out, right? Don't need that in there. What if I like do that? Okay, that's better than what I had. Okay. Trying to think, can I make this look any better? This is the range check, the runtime range check on the vector. So I could refactor that out, right? So it's just like a check. So it comes in as a signed integer and it comes out as an unsigned integer if it works. Yeah, why don't I do that? So this part, right? Refactor into function. Technically, I don't need the values. I just need to know the length of the values. Yeah, it gets the return value wrong. So I need to like manually refactor this. So copy that. So we're going to call this one vector index range check. Vector index range check. Okay, and then we need an index. Comes in as an I size, and then length is a U size. Result, U size comes out, or a string. And I think we also need a path, right? Yeah, we need a path. So we're just going to borrow the path. Path is a borrowed string. So values length gets replaced with length. And then let index equal that. And then we'll just do an okay index. Okay, that's fine. Then let's use it. Then I think I might be okay with this as it stands. So right, I have it as a class method right now, but I think we will want to move this out, right? Ugh, I'm fighting this and I shouldn't need to fight it. I had to hit the parentheses when I see that, right? No? What is it, tab? What am I supposed to hit? How come it won't auto-complete that for me? I don't know why it won't do it. Index values dot length. Borrow the path. Question mark, enter. All right. Okay, now it's a lot better than it was before. Can I merge that into the same line? I can. Okay, good. I'm going to do that. Okay. Whew. Oh, and I can put length in here. Even better. All right, it's just short enough to fit. Okay, so vector index range check can actually go outside. Completely out here. So I can remove the self : right? And then that's about it, right? Walk index path, walk reference path, evaluate reference indices, all need to use self. Evaluate index expression. There's no capital self anymore. Yes, walk index path. Oh, right, that's not using self. Okay, we're moving this one out too. Cool. And then get rid of the self in front. Okay. I think we're about to get some dinner going here, so I'm gonna have to end the stream soon. But let's see how much I can like wrap this up. Okay, I didn't refactor this one, but this should be easier, I think. And I can leverage some of the functions I just made. Like evaluating the index, right? This, where is it? Evaluate reference indices, right? No, I can't do that because that only works for the last part of the path. But this one, evaluate index expression, I can reuse that. In fact, let's try to reuse that one. Evaluate, I should be able to evaluate index expression way up here. Oh, except for oh wait, no, it doesn't actually use references to the component itself. It's just getting the index converted. So yeah, it's this stuff, right? After it's evaluated. Yeah. So here it's a use size. It's not a use size in here. It's wait, what? Hold on, I'm getting confused. Evaluate index expression takes an expression, which I shouldn't need to do AST in front. Should be able to just import that. Okay. So, right. I should be able to do it where we evaluate it. So it's actually more than one place. Why do we have two places for that? Okay, well that we can fix. Shouldn't I evaluate it first? Okay. For some reason I'm evaluating it twice. Oh, because the lengths are different. Yeah, but we can fix that now. It's either part iterations length or values length. Okay, so then it's this that we can replace, right? So I should be able to say evaluate index expression. There it helped me. Index and the path and right. And then I have to that does this part. Wait a minute, it doesn't compare with the length though? Oh, it only parses it. Okay, so I'd have to restructure this a little bit. We get it back as an U size, and I get to collapse these two. So we would match it. Well, no, we would get it, question mark, and then we would, it's an I size, yes. Might run out of time to do this. Oh, it's evaluate index expression. That's right. So I had to couple it with this, right? No, that's one we just used. It was the other one. Vector index range check. Yes. That's what I need to couple it with. So then it's vector index range check. How come it won't fill this in for me? Oh, probably because I need to do that. There we go. Right, so the index goes in here. Then the length, and then the path here. So this length is values length. And we get out a result, so then we would return early with that. Then we get a use size. Okay, cool. So then I don't need any of this stuff. We just index it. Easy. Look at that. Why is there a self? Mutable. Oh, this doesn't need to be mutable though. This can be immutable. Cool. We did it. Hey, kitty. The kitty came to say hello to me, but not chat. What happened to the path here? Why is this... Doesn't need a mutable reference. Why not? Oh, this mutates the path. This one doesn't. This one just borrows it as a string. Okay, got it. And we don't need this vector. We never needed that vector before. Cool. Okay, that's nice. This is not indexable. I already have a copy of that down here, right? That was walk. Okay, but this is in a loop. So if I took it out of, if I made a sub function that just uses one of these, then I'd have to make a mutable and an immutable version of it. But yeah. Hey there, Mr. Sir, how are you doing? Deleted code is best code. Hey, CM Griffing. My food time is coming up soon too. I've been going for 7 hours and 15 minutes because I am crazy. But I think all my unit tests still pass. Look at that, 487 tests. I am marathoning. I am indeed. So I'm working on the DataDisintegrator. I'm doing this for fun, and it's porting to Rust. This project I started in C++. So it uses a domain-specific language to parse data. Right? So for example, you might have this file, which looks like this, but to a computer it looks like that. You can see it starts out with like something that maybe we could use to identify the file, right? GIF89A. But then after that, we'd be kind of hard pressed to figure out what this means. So the idea is to write a tool that can be like a super hex editor, so that in addition to showing the bytes, it could also say what each of these bytes means. So the way that I want to do it, not just for GIF, but for any format, is to make a language where you can describe a format, and the tool will walk this data format along with the bytes and figure out what they all mean. Well, thanks for the raid, Mr. Sir. Yeah. So for example, GIF starts with a header, it ends with a trailer. There's a logical screen, which has a descriptor, which has the width and height of the GIF. So knowing that, we can go back to this and we can say, oh, well, there's the header and here's the logical screen descriptor. So here's the width and here's the height. And indeed, it is a 300 by 300 GIF, right? So we could do that by eyeball, but we'd be kind of hard pressed to like scan the rest of the file because it's just too many bytes, right? So that's what we have the tool do. So an example of how this works, you just walk it in order. GIF starts with the header. Header has a signature and a version. And these are instructions, like statements in the programming language, that say to actually do some parsing. So it says we're going to parse a string and name it signature, and it will be 24 bits long. So that consumes 3 bytes of the input, right? Then we check to make sure it's the correct signature. Then we consume 3 more bytes, make sure the version number is compatible. When we get into logical screen descriptor, we say, well, this is a Louis 16, and that is parse 8 bits as an unsigned integer, and then another 8 bits, and then you shift one of them left 8 and you add the other. That's how you do a little endian unsigned integer 16, right? And it just continues, and it processes all the bytes in the file. What I want to get to eventually is something like Wireshark, where we have a GUI that has like a hex editor part and like a data dump part. And then like when you click on one, it updates the other. So you can like either see what's in the file, or you can just click on a random byte and it says what that is. So pass 1 would be something like this. And then pass 2 might be once we've pulled out all the data blocks of a GIF, we might then decompress those data blocks and then use them with the color table to actually show the pixels. So you could imagine that you could click on a random byte in the file somewhere and it would say, well, that byte contains the compressed pixel values for this area of the image, right? We could do that. Or you can click on a pixel and it would say, well, that pixel is compressed in this section of the file. It's in data block 37, something like that. I think that would be kind of neat. And this is open-ended. You can describe any format. My goal is that you could do it for audio, video, streams, packets, save game files, you name it. So part of it is a compiler, of course. And I'm pretty much already done with that. So we use Logos for the lexer, and we use Lollipop for the parser. And for the actual data parsing, it's all custom. So it's really just running the program, so to speak, to convert the input bytes into an output data. Basically Wireshark ENBF, like for any file parameter. You got it. You got it, the epic unknown. So lately I've been working on one of the more esoteric parts of this. So like, you see how the data is inside of a loop? That means there's not just one data, but there's a data for every loop. If we were to keep assigning to data what we're parsing, we would be like overwriting data, right? So to prevent that, we have what I call vector context, which is when we enter a loop, we remember that we're in a loop. And every time we parse something, we make that a vector and we fill in the slot corresponding to the loop number. So if we loop 100 times, we'll have 100 data blocks. So data will be a vector of size 100. So there are some like interesting corner cases that you run into with that. Here's a simple example where we have 2 bytes and we parse it by looping twice and reading in an X with a unsigned integer X of 8 bits, right? It's pretty simple. You can kind of imagine what it's going to do. You're going to have X overall as a vector with the 2 bytes in it, and you can go to X's 2 iterations, and you can find that the individual bytes, and you can also find out where they came from in the input. Couple interesting things are, you can assign the overall value of foo to be a dereference of X, so we pick out the second byte, and we say that a copy of that value is also the value of foo. Then we get to the really crazy stuff. So you can have nested loops, and the nested loops can be conditional, which means you can create holes. So here, we parse 4 bits, but we don't do it for the first 2 loops. So that means in the output, there is no Y00 or Y01, they're holes. So we only have values for 2 and 3. But the second time through the loop, we do this one, and although we go 6 times, we only parse the first 4 times. So I opted to say that we don't create holes at the end, like 1, 4, and 1, 5 are not holes. We just don't do anything, right? It's kind of like it never sees that, so it for all it knows, it stopped at 3. So you can make disjoint parsing results where X spans a distributed area of the file and you need to stitch them together later. So even though the 12 and the 34 came from different areas of the file, they come together in one vector. And the same thing with the y's, right? The y's has an interesting structure because it's two-dimensional and it has the two holes in it. So this took a lot of work to get right, and especially the dereferencing. So there's two ways to dereference. You can, in a context where you're just copying a value out, that's pretty easy. But then I ran into this case where you have a vector already and you want to use it on the left-hand side of an assignment or accumulate. Now we need an L value reference. So that gets really tricky because I don't want to support or allow a parsed value to be updated. We'll only allow copies or local variables to be updated. And because we're dereferencing and then operating on it, we need a mutable reference into that data structure. So it got pretty hairy here. The code is, I've refactored one of them. So it's essentially, we need to pre-compute the indices first, because once we start descending down the reference path, we can't use self anymore, because this self reference comes back out as the part. And then that part value, it goes in and it comes out as this value reference. So we can't use self anymore. And we need self when we're evaluating the indices, because each index is a reference and you have to use self to evaluate it, because self has the expression evaluator. And that's because one kind of expression is a reference, which recursively calls back into dereference. So in order to support that recursion, we can't have a mutable reference. So we have to do that. We have to do that up front. Get the indices out, pre-compute them. Then we can walk the reference path and the index path. And these were all smashed together one function before, and I was successful in refactoring them out to 3 different functions. So they're a bit easier to read. Still a little gnarly in a few parts, but not too bad. Walk reference path, a little bit gnarly, and that's because while we're walking through the path, sometimes we insert when we need to, and this is all mutable, so we're doing into mute and get mute, and yeah, we have to be really careful that we don't upset the borrow checker. And we can't do the normal thing, which is when in doubt, clone it out, because we actually need to update the original. That's why we're returning mutable references. Yeah, walking the index path is not as bad, because I refactored this out to do the range checking here. So, oh yeah, we support negative indices by adding to the length and then casting back to an unsigned integer, which is kind of interesting. So you can, if you do a index of -1, it takes the last instead of the first. -2 would be the one before the last. So I got to go get my own food soon, and there's this huge thing I still need to refactor it. And that's what I was in the middle of doing just now, right? I think I was trying to, right, I was able to reuse vector index range check and evaluate index expression here to shorten this a bit, but there's still all this stuff down here. Yeah, so here again, we're doing the evaluating an index, so I should be able to use this evaluate index expression, at least to do part of it, right? So this part of it, I think. Actually, a lot of this. So it actually splits it, right? So we evaluate it, and that gives us, if successful, assigned int, and then we want to do this conversion back to unsigned, like this. And to do that, we have to use the part iterations. Yeah, I remember this. Okay, so it's kind of want this, right? Over here. So let index v vector index range check self, evaluate index expression, index mute path, and then instead of values length, we want part iterations length. I think that's what we want. And then I think I can delete all this code and it'll still work. Delete, delete. Okay, cool. When deleting code works, then that means you're on the right track. If you can delete code and make all your tests still pass, you either don't have enough tests or you have successfully refactored. Index should be valid for part iterations. That's because we do the range check inside here, but we don't actually do a get. I guess I could do a get. If I did a get, then that would give us this directly. Why can't I do that? Because it's only passing the length in, because otherwise I'd have to give it another reference that I can't spare. Yeah, I think it's fine for now. And then what's this up here? Blah, 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 blah. Okay, yeah. I don't think I can shorten this one. Oh, hey there, kitty. Trying to sneak past me, huh? Failed to catch her that time. She jumped away. All right. Yeah, I think I gotta end soon, cause I'm hungry and I'm tired. But I do want to do another round of refactoring here. So what if I leave the to-do refactoring? This one I think I'm done. So I'm gonna delete that line. That one's refactored. These are uncomfortably indented, but I think they're okay for now. Yeah, so I just have this one function I want to refactor, the dereference function. That's 100 lines long, or actually 90 lines long. And mostly it's this inner thing. So maybe if I refactor that if statement out, it would actually look a lot better, right? So this is like indexing into a vector component. Hey there, Adjective Allison. You and one friend have rated me. How are you doing? Welcome back. I might stream later, but it is getting kind of late and I need to catch up on sleep, so I'll probably stream tomorrow though, but maybe not anymore tonight. Okay. And I didn't break anything just now, right? You started having a code. It's not December yet. You must be doing a previous year. Which year? Are you doing like last year? I think I only got like 5 days into last year. And then I kind of gave up. Okay, so you're doing last year? Yeah. Don't start with the first year. That was really hard. I think the year before last was not too bad. I can't say what last year, if it was good or bad, or easy or hard, because I only got like a few days into it. Okay, I'm leaving that to do. I just want to kind of see like what else do I have to do? Factor out the match. Yeah, my brain is telling me that I shouldn't look at this right now. Oh, right, I remember this. Basically, just statements returns an error. Does this make the parser continue despite hitting an error? For a conditional, I think the answer is does not continue. I think we answered that because this, if I look at the call hierarchy, goes up to here, which captures the result and marks the composite as an error and does an error return scope, which goes back to like this, which goes back to here. Hold on. Here? Yes. Which goes back to here. which goes back to here. And this does a check at the very bottom, and it says, if there was an error, then stop parsing. That error comes from here. Yeah. So we retrieve the error out if anything failed in to parse for that part, and we were in a part of something else, then we reflect it back. If the return scope was error, sometimes an error can be eaten, and it would skip this if, and it would still mark the composite as an error, but it would return okay, and we would continue going. So I think the answer to this is no. But should I have a test for this? The test for this would be, we enter a conditional like an if, we hit an error, we should make sure that the thing after the if doesn't execute. So yeah, let's do a quick test. Conditional. So I don't know, it doesn't matter. Let's just pick one. So let's have a test. Test error in if stops parsing. So let's do it this way. We'll have foo and we'll have a bar. Okay. And we'll have something inside the statements. This is the else, right? Yeah, if we have an else. So actually, let's just test this one first. Yes, so this is if you hit an if, or then block for an if, and that's an else. So if true, then let's do an error. So an error would be something like, try to parse like a gazillion bits, right? And we'll just keep it simple. So it would, let's just have a bar, and then we'll have something after the bar that just parses a bit, right? So really, I don't care about anything other than that we reach offset 1. And foo should have an error. No, we should not hit offset 1. We should be at 0. Because that's an error we can't recover from. So assert foo.error. Okay. Run the test. It passed. Okay, and we even got some cool diagnostics. Inner bound 1000 surpasses outer bound 8. Unable to parse UI. Unable to parse bar. So it couldn't parse that. Couldn't parse that. Makes sense. Cool. Let's test the else just to make sure, and then I can remove those to-dos. So this is test error in else stops parsing. So that's easy. We just do it if false. I mean, if false. Oops, I completely barfed down on that one. Yeah, okay, try again. If false, else. So here we'll put something reasonable, like UI, which we're going to ignore, 2 or 5. How about 5? So here it'll go into the else, it'll crash, it'll error out, and then it won't get to that statement. Cool, it passed. Unable to parse UI, unable to parse bar. Okay, cool. So I can go in here, and this is not a to-do anymore. Waha! We have finished 2 to-dos. Oh, right. Can I reason out how to do okay or with this, or do I need more brain power to do this now? So match u.sub check sub to if it's something. Okay, yeah, I think so. Can't I say that u equals u sub checked sub okay or error. Actually, I don't even need to say error. I just put the string in there, right? And then that. There we go. I did it. Yay. Actually, I'm not done yet. I need to do that down here now, right? In fact, I need to do, no, that's the only other place. Yeah, so it's the same thing. It's star I equals check sub dot okay or that string. Done. Nice. Is this still valid? Make a function wrapper that returns an error. No, I don't need to do that anymore because we're just using the question mark operator. That's done. Same thing here, right? Yeah, we don't need to do that. And there's more okay ors, so we know how to do that. That's that dot okay or. And I equals that okay or. Easy. Oh, we found out that Flippy will only complain with this if I turn on verbose warnings. So that to do is resolved. Cool. Actually, I'm running out of to-dos, aren't I? What are all these? CPPs? I don't care. Why don't we just tell it to ignore, like, packages and async data and Cocoa UI or Cocoa GUI and system abstractions. These are like really old libraries that I need for the C++ version, but I don't need them for the Rust version. Okay, that's a lot better. Okay. Yeah, you will undoubtedly regret uncommenting this line. So I learned that pedantic gives you a lot of warnings, but nursery gives you twice as many warnings. But some of them were kind of useful, so I might go back and look at that again. Actually, I don't think they need this type anymore. Yep, I don't need it anymore. We're deleting it. Deleted. This entire file can go. Deleted, move to trash. We don't want to see it anymore. No mod error. It's gone. Should not affect our tests. Completely unnecessary type. Got rid of a to-do at the same time. Okay, actually, we're getting close to being done with to-do, so I like this. I like that I'm almost done. Still need to refactor that. Still need to do that. A better way of doing that would be nice. Support possible starting point. Yeah, we need to do that. And this is just the same thing 2 more times. Consider refactoring. Do I want to do this now? The unwrapper else really goes with the build part. What unwrapper else? Oh, we got rid of that one. Yeah, so this is gone. Already refactored that. Yep. Cool. So I've only got 12 things. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's only 10 because we're ignoring these two. Can I X those out? Ooh, I can. Sweet. Just say I don't care about those files. Nice. Okay, we're in a pretty good state, right? We only have 10 to-dos left. The unit tests all pass. There is a little bit of work I just thought of. We fixed accumulate, but I didn't fix assignment, increment, or decrement. They're still broken. That's fixed. What if we put here fixed? Can I do it on like a second level? I can. Fixed accumulate. How about we say fix accumulate and then mark that as done. Alt D, okay. Fix assignment. fix increment, fix decrement. And let me do a quick check to make sure that there are no other places where I need to do that. That would be in the grammar, right? Wherever we have an L value reference. So where do we have that? This ref, right? Ref. So assign, accumulate, increment, decrement. Oh, we still have the op assign. Is that okay? I need to do a separate search to see if we still use that. There's where it's defined. Okay, in expression, we don't need an L value reference. Okay, so that's the only places then. Yeah, this op assign, do I still use that? No. So I can actually remove that from the grammar. Although I was thinking about adding that back because I removed that, but then that makes it incompatible with the C++ parser. It was just an alternate syntax to make a copy of a part and save it as a local variable. So I might add that back. Let me add the to-do for that, and then we'll finish up. So add back op assign grammar to part statement for backwards compatibility. Compatibility with C++ version of the code. Code is spelled C-O-D-E. Huh. Okay. Yeah, because I want to do a performance test at some point to compare the C++ and the Rust versions to see which one's faster. And I want it to be a fair test, so I wanted them to be able to be using the same grammar, the same inputs. Which one can parse it faster? We'll even like not output anything. We'll just compute only. Just input and compute only. And we'll see which one's faster. So yeah, I really got to take a break now. Who are we gonna raid? Oh, we could raid Chris again. He's cooking some fried chicken. I wouldn't mind watching that. Watch him cook some fried chicken. Yeah, we're gonna do it. Because I can. Here we go. I wonder if we can talk to him now. Has he fixed that? How come it won't let me raid him? Is he not going anymore? How come I cannot raid him? I guess I have to type it in. Griffing and chill. There we go. How come it's NA? And not, like, cooking stream. Anyway, I'll be back later. If not later, then tomorrow. Have a good evening or a good day. Bye.